Welcome to this masterclass on Hibernate and JPA with Spring Boot. I am Ranga Karanam and I've been using Hibernate since 2009. That's almost 8 years of experience with Hibernate and JPA. In this course, we take a deep dive into JPA and Hibernate. At the beginning of the course, you'd understand the world before JPA, JDBC and Spring JDBC. We would develop a simple JDBC application and migrate it to JPA. In the advanced part of the course, we would learn about entities, annotations, relationships, inheritance hierarchies, and also the most important concepts in JPA, entity manager and persistence context. We'll also find out what are the different ways of querying data with JPA. We'll learn about JPQL, native queries, and also using the criteria API to define queries with Java. We'll also focus on transaction management and performance tuning. We would learn how to do caching with a first level cache as well as second level cache with EH cache. While focusing on JPA and Hibernate, we would also make sure that you'd understand the basics of Spring, Spring Boot, and JUnit. This course has more than 100 steps to help you to become an expert on JPA and Hibernate. All the details of the course, complete code examples, and the step-by-step details are on our GitHub repository in 28 minutes JPA with Hibernate. At In 28 Minutes, we ask ourselves one question every day. How do we create more effective courses? The success we have on YouTube and Udemy with more than 80,000 students is a result of this pursuit of excellence. And this course is no exception. We expect you to have very good experience with Java. That's all that you need to be able to successfully complete this course. We will help you to install all the tools needed: Eclipse, Maven, Embedded Tomcat, and also the embedded database H2. What are we waiting for? Let's have some fun with Hibernate and JPA in more than 100 steps. We had a lot of fun creating this course, and we are confident you'll have a lot of fun too. If you are excited to learn more, go ahead and enroll for the course. Or you can take a test drive using the free preview feature. I'll see you in the course. Welcome to this course on Hibernate and JPA with Spring Boot. We are excited to help you learn JPA and Hibernate in depth. In this video, we introduce you to the different sections of the course, and by the end of this video, you should have a clear idea of how to make the best use of this course. We have organized this course into 7 different sections. We have designed these sections to be independent of each other. That means you have the flexibility of customizing this course based on your skills and your immediate needs. We start with a quick section on Introduction to JPA. In the next section, we would get introduced to Spring Boot in 10 small steps. We would understand the world before JPA and create a simple JDBC application and migrate it to JPA in the section Journey from JDBC to JPA. We would introduce you to JUnit in 5 simple steps before taking a deep dive into Hibernate and JPA. This is the most important section of the course where we would take more than 85 steps to talk about the important concepts in JPA. We would talk about entities, annotations, relationships, inheritance hierarchies, entity manager, and persistence context. We'll also talk about how to query the database using JPA, JPQL, criteria API, and native queries. We'll also talk about transaction management and performance. We will implement caching using first and the second level caches as well. If you are new to Spring, then we would recommend you to do the section Spring Framework in 10 Steps, which is present in the appendix at the end of the course. So if you are new to Spring, or if you want to quickly review the Spring concepts before getting into Spring Boot and JPA and Hibernate, this section might be really interesting for you. It's at the end of the course in the appendix, Spring Framework in 10 Steps. So in summary, we start with a quick introduction on Spring Boot before moving into the world of Spring JDBC and migrating the application out to JPA. After that, we discuss JPA and Hibernate in depth in more than 85 steps. The appendix section on Spring Framework would help you if you are new to Spring. This is your course. Feel free to create your own path and tailor it to your needs. I'll see you in the next video where we'll introduce you to our GitHub repository. Welcome back. In this video, we give you an overview of how our GitHub repository is organized. The GitHub repository for this course is JPA with Hibernate. It's github.com in 28 minutes, JPA with Hibernate. Homepage of this repository contains an overview of the course as well as the installation guide. For each hands-on section of the course, we have a separate folder in the repository. Each of these folders contain step-by-step details of each section. The complete code details as they are at the end of the section, as well as a few intermediate backups at different stages of that specific section. For example, let's look at the folder for 02 JPA Advanced. This is the home page for the Advanced JPA section of the course. As you can see, this page contains step-by-step details. What are we going to do in each of these steps? The complete code example as it is at the end of this section. The complete code example will be of great use if you have any question on what we are doing in a specific section. For example, if we are using a criteria query and you don't know which package the criteria query is present in, all that you need to do is to search for criteria query in here, and you'll be able to see that the criteria query is in the package JavaX persistence criteria. Not just this, but any other questions that you would have, you can come over here and check the code out. Also present are the intermediate backups at different stages of this section. You'd see that there are more than 40 intermediate backups which are present for this specific section. You can download these zip files and you can import them into Eclipse as Maven projects. Understanding the GitHub repository is a key part of making the best use of this course. I recommend you to spend some time with the repository, and I will see you in the next video. Welcome back. In this video, we will help you to install all the basic tools you need to get started with the course. In this course, we'll be using Eclipse as the IDE and Maven for dependency management. If you go to the home page of our GitHub repository and scroll down, you'd find a link to the installing Eclipse, Maven and Java. The step-by-step details to install all these tools are present in our GitHub repository. You can take the link from here, so github.com in 28 minutes, getting started in 5 steps. You'd see the step-by-step details over there. Also present here are links to the companion videos for installation. This is a set of 5 videos which would help you to install Java, Eclipse and Maven. In this course, we are going to use the embedded Maven in Eclipse, so you don't really need to install Maven as such. What we'll do is we'll use the Maven which is already present in Eclipse. There's also a troubleshooting section which would help you to troubleshoot any problems that you would be facing while doing the installation. If you face any problems during the course, we recommend you to look at the troubleshooting section of the installation playlist. That's the video number 5. Watch these videos and get your tools ready, and I will see you in the course. Welcome back. In this video, we'll get a quick preview of what JPA is and what are the different things that are related to JPA that we would be learning during this course. Before we talk about JPA, let's talk about JDBC. JDBC or Spring JDBC, these were the approaches which were present before JPA. In these approaches, what we were doing is we were writing a lot of queries. So we write queries whenever we need to do any operation on the database. So if I want to insert a new person in, what I would need to do is I would need to create a query and I would need to populate the right values into the query and fire it into the database. So whoever is writing the Java code should also know SQL. That's how to write your queries. The queries which we are looking at right now are quite simple. I've worked in applications where these queries run into hundreds and hundreds of lines. Over a period of time, applications which were developed with JDBC and Spring JDBC become very difficult to maintain. That's where JPA comes in. JPA stands for Java Persistence API. JPA says, Java programmer, you don't need to worry about queries. All that you need to tell me is what are your Java classes, what are your Java objects that you are creating, and how do they map to your tables. JPA says, tell me all about your objects and also tell me about how they would map to the tables in the database. With JPA, all that you need to do is to tell JPA that these are my objects and these are the tables they map to. Once you do that, JPA would take care of creating the queries for you. If you look at this example which was written using JPA, you don't see a query present at all. So to find a person, to update a person, or to insert a person, we don't really need to write a query at all. With JPA, attention shifts towards defining your Java objects and defining the relationship of these objects with your tables in the database. This is called defining your entities and mapping your fields to the column in the database. The other important things that you would define with JPA are the relationships between the objects. The objects which we would store to the database are called entities. For example, we put an @entity annotation over this course object. What would happen is now this is an entity. This is something which would be stored down to the database. There would be relationships between these entities. Let's take a very simple domain, right? So there are a lot of courses and there are a lot of students. A course can have multiple students and students enroll to multiple courses. In addition, students also can leave reviews over these courses. Something like a passport is used to uniquely identify a student. So in this domain, you can see that between the different entities which are present, there are relationships. Consider the relationship between course and student. A course can have multiple students and a student can be belonging to multiple courses. This is called a many-to-many relationship. Consider the relationship between a student and a passport. A student can have one passport and one passport can only be associated with one student. This is a one-to-one relationship. And let's consider the relationship between a course and a review. A course can have multiple reviews, but a single review is always associated with one course. This is a many-to-one relationship. So in JPA, what we define is A entities. After that, we also define the relationships between the entities. You can see here in the course entity, we are defining a one-to-many relationship with reviews. A course can have many reviews, and a course can have many students as well. And the relationship of course with student is many to many. We will understand the details of all the annotations and the options that are present later in the course when we talk about relationships. JPA also provides different ways of querying the data from the database. By default with JPA, you don't need to write any queries at all. But in certain situations, you might want to write a few queries. And in those situations, there are three different options that are present. One is called JPQL. In JPQL, we write queries using entities. Here, the course is referring to the entity course, to the Java object course. It is not referring to the table course. So in JPQL, we write queries using the Java entities. The other option is to not use SQL at all. You can use something called criteria query to build the entire query using Java API. This is called criteria queries. The last option JPA provides is to use your native queries directly, is to use your SQL directly. In this quick video, we got a quick overview of the important concepts in JPA. We talked about entities, we talked about defining relationships, and we talked about the different query methodologies. JPQL, criteria query, and also native queries. All the code you have seen is what we would be developing step by step during this course. If you are new to JPA, this might be a lot of information bombardment. There might be a lot of new terminologies you have heard for the first time. Don't worry about them at all. We would introduce all these to you one step at a time. Welcome to the world of JPA. I hope you have a great time learning JPA in this course. Until the next step, bye-bye. Welcome to this section on Spring Boot in 10 steps. If you are already an expert on Spring Boot, then you can safely skip this section. However, if you are new to Spring Boot, then I would really recommend you to spend some time in here. If you are new to Spring Framework, then I would really recommend you to go to the appendix and look at the introduction section on the Spring Framework. It's called Appendix Spring Framework in 10 steps. You can do the Spring Boot section after you complete the Spring Framework section. Now, what would we do in this specific section? We would talk about the world before Spring Boot. How are things done before Spring Boot? And what is the magic of Spring Boot? What are the important concepts of Spring Boot? Spring Initializer, Spring Boot Auto Configuration, Spring Boot Startup Projects. We would also take a quick look at Spring Boot Actuator and Spring Boot Developer Tools. The GitHub folder for this specific section is in the GitHub repository. Go to Framework Tool Introductions and go to the folder Spring Boot Introduction in 10 steps. This is where you have details of all the 10 steps as well as the complete code example at the end of this section. I welcome you into the world of Spring Boot. I'll see you in the next step.
Welcome back. In this step, we will get the big picture of Spring Boot. What are the goals? What Spring Boot is not? And what are the features? Today, world is moving towards microservices. Instead of developing large monolith applications, we are building a lot of microservices. So instead of building one big application, we are building 20, 25, maybe 50 smaller microservices. One of the important things with these microservices is you'd want to be able to build them quickly. That's where Spring Boot comes in. In the last couple of years, Spring Boot has gained a lot of ground. It has quickly become the #1 framework to develop microservices in the Java world. How did Spring Boot achieve this? That's where we would discuss about the goals and the important features. What are the most important goals of Spring Boot? The most important goal of Spring Boot is to enable building production-ready applications quickly. The other important goal is to provide all the common non-functional features: embedded servers, metrics, health checks, and externalized configuration. We'll talk about these features a little later. These are the two important goals of Spring Boot. A, to enable you to quickly build applications and also provide common non-functional features. Before we go more in depth into Spring Boot, you also need to understand what Spring Boot is not. What Spring Boot is not is there is no code generation at all. Some of the people call Spring Boot as a code generation framework. Actually, Spring Boot does zero code generation, and that's what makes this concept really great. The second thing is Spring Boot is neither an application server nor a web server. Spring Boot provides great integration with embedded servers like Tomcat, Jetty, but by itself, Spring Boot is not a web server, it's not an application server. These are two things that you need to remember. There is no code generation with Spring Boot, and Spring Boot is neither an application server nor a web server. Now that we understood the goals and also understood what Spring Boot is not, let's look at how Spring Boot achieves these things. The most important part of Spring Boot is this concept called starter projects. Consider an example of developing a web application. If let's say I want to develop a web application, I would need Spring MVC, I would need Spring Core, I would need some validation framework, I would need some logging framework. In addition to that, I would need to configure all this stuff that is needed. For example, if I'm using Spring MVC, I would need to configure dispatcher servlet, I would need to configure view resolvers, and a lot of things like that. However, with Spring Boot starter projects, it becomes very easy. All that you need to do is to add a starter called Spring Boot Starter Web into your project, and that's it. You get Spring MVC for free, you get Spring Core for free, you get a validation framework for free, and also a logging framework for free. Similarly, for JPA, there's a starter called Spring Boot Starter JPA. Once we use this starter, you would not only get JPA, but also a default implementation of JPA with Hibernate and also auto configuration of that. So you would not need to worry about the framework part, and you can directly start creating your entities. Another important feature we already talked about is embedded servers. Let's say I am developing a web application. I would want to deploy it onto a Linux box. In the olden days, the way it used to work is first I would need to install the Linux box, then I would install Java on it, and then I would need to install a web server. So I would need to install either Tomcat, WebLogic, or WebSphere, and then I would take my application var and deploy it. This is the usual way we used to deploy stuff. With Spring Boot comes a concept called embedded server. What you can do is you can package your server. So you can package Tomcat along with your application jar. So I can include the Tomcat server in my application jar. So I don't need to install it on the Linux box. So all that I need to do on the Linux box is if I have Java installed, that's sufficient. I can go ahead and run my application. I don't need any other server installed on the Linux box. In the world of microservices, this makes a huge difference. And also, Spring Boot provides a number of production-ready features. Spring Boot provides monitoring for your application through something called Spring Boot Actuator. For example, you can find out how many times a particular service is called. You can find out how many times a particular service failed. And also, you can check whether the application is up and running or not. All these features come built in. And another important feature that Spring Boot provides is externalized configuration. The configuration of applications varies between different environments. Your configuration from dev different from your configuration in production. Spring Boot provides these features built in. You can simply create property files matching a simple naming convention, and that's it. You are ready with externalized configuration. Spring Boot also provides support for different profiles. These are some of the important goals and features of Spring Boot. The idea behind this step is to understand the big picture of Spring Boot, what it is not, and what are the important features. In the next steps, we would dig deeper into each one of these things. Until the next step, bye bye. One of the best things to do to understand the beauty of Spring Boot is to understand how things were done before Spring Boot. In this step, we will look at one of the projects which we developed in our Spring MVC course. Before we start with any project, we need to decide what frameworks and dependencies to use. This was a web project, so we would want to use Spring MVC and things like that. So we needed to make decisions on what frameworks and what versions of them to use. We needed to decide I would want to use Spring Web MVC. I would add Spring Security Web, Spring Security Config. I would want to use Jackson Data Bind because I want to do some binding and validation. I would want to use JSTL, and I would want to use Hibernate validator. And also for logging, I would want to add in Log4j. We had to decide what dependencies to add into our projects. Not only that, we needed to decide the versions of them as well. Sometimes this 5.0.2 final version might not be compatible with some other version of Spring MVC. So you needed to decide what are the compatible versions and start using them. Choosing the frameworks to use and which versions to use is a major decision that we needed to make when we were not using Spring Boot. We needed to implement default exception handling. You can see that here we are just implementing simple default exception handling. And we needed to create a complete Spring configuration file. We needed to define the component scan. Then we would need to configure a view resolver to redirect the views to a JSP. To implement internationalization, we needed to implement a message source and also a locale resolver. And in addition to that, we needed to configure our web.xml as well. We needed to configure the dispatcher servlet in web.xml so that it can handle all the requests and act as a front controller. We needed to configure the context configuration location in here, and we also needed to configure Spring Security. We needed to configure a filter for it and make sure that it intercepts all the requests. There is a lot of work that you would need to do to get a simple web application up and running. We configured dependencies, dependency versions, Spring configuration, configuration for internationalization, logging, and a lot of other stuff. All this stuff which we looked at in this specific step is the kind of stuff which you don't need to do with Spring Boot. Spring Boot would automatically provide all that stuff for you so that you can really concentrate on developing your business logic. All the infrastructure would come free for you. The idea behind this step was to give you an idea of the world before Spring Boot. If we directly jump into Spring Boot, you might not really appreciate the value that Spring Boot provides. All the stuff which we looked at in this specific example would be replaced by a simple startup project called Spring Boot Starter Web in combination with Spring Boot Starter Security. Just the combination of these two starters would eliminate the need for a lot of configuration that we looked at in this specific step. We will look at those starters and a lot more about Spring Boot in the subsequent steps. Until then, bye-bye. Welcome back. In this step, we will create a simple Spring Boot project and look at all the magic a simple starter project can provide. The way you can create a Spring Boot project is by going to start.spring.io. It's very simple. Start.spring.io. Just do a Google search for Spring Initializer. You should be able to easily get here. Start.spring.io. Once you are here, I would need to choose. I would use Maven as my build tool, Java as the language. You can use any version of Spring Boot which is greater than 2.0. I'll use 2.000 snapshot. I hope by the time you do this course, there would be a greater version of 2.0 as well. You can use any of those versions. And over here, I would need to configure a name for my project. Just like you give a class name and a package name to each class, you would need to give a group ID and an artifact ID to each Maven project. So I would go ahead and give that. So com.in 28 minutes dot spring boot basics, and I'll call this spring boot in 10 steps. And to this you can add startup projects. Startup projects makes it very easy to develop applications. We would want to develop a simple REST service, and to be able to develop a REST service, we need to use a web starter. So we will need to use Spring Boot Starter Web. So I'm adding a web starter. You can see that in here. So you can see that there is a web added in here. Now you can go ahead and generate project. Once you click generate project, a zip file would be downloaded to your downloads folder. What I would need you to do is to take that zip file, unzip it to any folder on your hard disk, and note down the path to that folder. I'll click generate project. This would download a zip file. I have unzipped the zip file to a folder on my hard disk. In 28 minutes, getting started in 5 steps. Spring Boot in 10 steps. You can actually unzip it to any folder on your local hard drive. I would go into Eclipse and import that project. So what I'll do is file, import existing Maven projects, and you can either paste in the directory where you unzipped it to, or you can use the browse to that specific directory. Either of these things should be fine. Once you are able to successfully select the root directory, you'd see a Spring Boot in 10 steps, a pom.xml. So I would go ahead and click finish now. What would happen in the background is now Eclipse would look at the Maven configuration and start downloading all the other stuff that is needed. So you would see that it would start to download all the dependencies and all that kind of stuff. If this is the first time you're using Spring Boot, then this might take a little while. It might take a few minutes for the whole configuration and the creation of the project to complete. The entire thing has completed, and now if you look at it right now, this is the project which has been created. We have a folder called source main Java where all our Java code is. Source main resources is the resources folder. One of the files which would be there is application.properties. We'll talk about it a little later. Source test Java has the tests. Other than that, you should see a lot of Maven dependencies which are coming in. You can see that there are a wide variety of dependencies that are coming in right now. We will look at why these dependencies are coming in a little later. For now, let's see if we are able to start this application up. So I'll open up Spring Boot in 10 steps application, and I would right click and say run as Java application. Actually, we have not really implemented any code as such, so there is nothing that is implemented right now. All that we are looking for is to see if the server has started fine or not. You would see something like this: started Spring Boot in 10 steps application in 8 seconds on port 8080. And if you looked at the details of the log, you would see that there are a lot of things happening already. However, the most important part was the fact that you have now a web application up and running. We would look at the different things which are present in this log and understand what is happening in the background a lot more in the future steps. Until then, bye-bye. To understand the magic of Spring Boot further, let's create a simple REST controller in this example. What we'll do is we'll create a simple REST service. I would want to create a REST service with the URI spring like books/books, and I would want to return a few hard-coded books. Since the Tomcat runs on port 8080 by default. That's what we saw, port 8080. So the URI would be something like http://localhost:8080. And I would want to return a few hard-coded books. Before we go to the REST controller, let's create a simple bean. So I'll create a new class. I'll call this book. Let's not really make it a lot complex. I'll just say a long ID string, name of the book, and string author. We can store a lot more details like ISBN, copies, and things like that, but let's keep it simple. Let's just have these options which are present in this group, in this book. Let's also create a constructor quickly. And also, I would want to create the getters and setters. I don't really want to create a setters, but I would want to add in the getters. So I'll say select getters, and I've added it in, and I'll add in a toString as well. Okay, cool. We have a simple bean defined right now. So we have a bean with ID, name, and author. Now I would want to start creating the REST controller. So how do I create a REST controller? Again, it's a Java class, and I would want to call this books controller. So I would want this to be a REST controller. I would want it to serve requests, REST requests. So I'll need to use the annotation. Let's import this in. Now I have a REST controller annotation added in. Now I would want to map a URI to it, right? So the one which I want to map is /books. So I would want to map /books. So whenever somebody executes a GET request on /books, I would want it to return a set of hard-coded books. So how do I do that? That's by GET mapping. So I'm mapping a GET URL. So I'm mapping a GET URL for what? So GET is the type of the request. So if you understand HTTP well, then you would know that there are multiple types of HTTP methods, right? GET, POST, DELETE. GET is typically used to retrieve data. So I would want to use GET. Let's create a method. So public, and I would want to return a list of books back and get all books. I'll import java.util.list, and now I can actually return a simple. I would want to create a book, so I'll say new book. I'll use an ID of 1, and I can use one of the recent books I have written. So I'll say Mastering Spring 5.0 is the name of the book and authored by Ranga Karanam. All that we did is very simple things, right? Add a REST controller. Method would handle a GET request to this specific URI. And what we are doing here is we are actually returning a book. We can actually return multiple books if you would want to. For now, I just wanted to keep it simple, and I just wanted to return one book back. Now, I would actually go ahead and now start up the server. I'm running it as a Java application, Spring Boot in 10 steps application. The server has started up, and in the log, you can see that there is our mapping has also been picked up directly. So you would see that /books get method is mapped onto the method which we wrote, get all books. So let's see what would happen when I execute the request. Localhost 8080/books. You can see the server respond back with a JSON response. This is a JSON response. ID 1, name is Mastering Spring 5.0, author is Ranga Karnam. So this request is actually returning back the details in a JSON format. This is a REST service. The magical part of the whole thing is the fact that we have directly focused on creating the REST service. That's what Spring Boot aims to enable. We have not focused on any of the infrastructure stuff. We did not focus on either configuring a framework or configuring some beans or configuring a dispatcher servlet or configuring a view resolver. We did nothing. But still, magically, this service starts working. How does this happen? That's what we would learn in the next few steps. In the previous step, we were able to create a REST service very easily. In this step, we will understand what is auto configuration. How did all the things that are needed for a REST service to be up and running get configured automatically. Let's look at it in this step. We have the Spring Boot in 10 steps application where we have the at Spring Boot application annotation. The annotation at Spring Boot application indicates that this is a Spring context file. That's number one. Number two, it enables something called auto configuration. Number three, it enables something called component scan. Component scan is one of the important features of Spring where it would start automatically scanning the classes in this package and this sub package for any beans. So we have added in an annotation at REST controller. This is one of the annotations which is scanned first. So this would be registered as a component. So the book controller would be registered as a bean and it would be managed by the Spring framework. There are three things that are essentially done by the at Spring Boot application. It indicates that this is a Spring context. The second thing is the fact that this enables auto configuration. The third thing is that it enables automatic scan of this specific package. Now, we want to look at auto configuration in depth. Spring application.run method is used to run a Spring context. So I'm giving a Spring context as an input to it and it would be able to run that. The run method also returns something. So it returns a application context. So I'll actually get the application context back. So I'm getting the application context back. This returns the application context. So I'm taking it and I would say I would want to loop around it. So for each control space actually, I would want to loop around the application context dot get beans. I want to get the names of all the beans which are configured and I would call this name and I would want to log them. I'll for now use a sysout. Taking a shortcut here, ideally I should have been using logger, but I'm a lazy guy. I would go ahead and print all the beans which are present in here. Let's see what would happen. Run as Java application. Okay, I'm getting an error saying it's failed to start because 8080 is already used. Let's see. Yeah, it's already being used. I'll kill that and let's start again. Okay, cool. There are a lot of things that are printed right now. So there are a host of things that are getting configured for us automatically. How are these being configured? That's basically the feature called auto configuration. What Spring Boot does is, as part of the Spring Boot framework, there is something called Spring Boot auto configure. So if I look at one of the dependencies is Spring Boot auto configure, and this Spring Boot auto configure has a lot of logic built into it. So you can see that there is a lot of classes that are written. So if you look at the auto configuration jar, it's a very big jar, and if we go to the web, we will find auto configurations for all the things that we are looking at right now. I'm going in to the auto configure web servlet and you would see something called dispatcher servlet auto configuration. These auto configuration classes are what are creating these beans. What would happen at startup is the Spring Boot framework would trigger the auto configuration jar and it would look through classes which are on the class path. So it would see that, okay, do I have a specific class on the class path? It would see that I have a Spring Web MVC framework on the class path. What does the Spring Boot auto configure do? It says, oh, there is Spring Web MVC on the class path. Then I would need to configure a dispatcher servlet. It would say, oh, there is Spring Web MVC on the class path. So I would need to configure a view resolver. So all those kind of things happen and you'd be able to see all the beans which are created in here. How does auto configuration work? Spring Boot basically looks at two things. One is frameworks available on the class path. This is a website called springboottutorial.com where we have a lot of articles on Spring Boot. I'm referring to one of the articles there. So Spring Boot looks at A, the frameworks which are available on the class path. And also B, it looks at the existing beans which are configured for the application. And based on that, it provides the configuration needed. So for example, if you are using a web starter, The basic things that you would need would be a dispatcher servlet. You would need probably some internationalization. You would need some messaging. All that kind of stuff would get auto configured for you. Now we are looking at one of the auto configuration beans, which is data source auto configuration. If you see the code of data source auto configuration, which is inside the Spring Boot auto configured jar, you would see that it's conditional on class data source.class and embedded database type.class to be present on the class path. So what happens is only if these classes are on the class path, then this specific bean would be created. The data source bean would be only created when these are on the class path. You can see the code in here. So database auto configuration is conditional on a specific class being available on the class path. You can also see another example in here. So embedded data source database configuration. This is only created when there is no data source, when there is no bean created with a data source or a XA data source. Spring Boot would then create an embedded database configuration for us. If you want to find out more about what auto configuration is happening, what we can do is we can turn on debug logging. What I can do is go to application.properties. That's one of the files which is present in here. We'll talk about application properties a little later. I'm turning on the logging level. All that you need to do is say logging.level.org.spring framework is equal to debug. This would start the application in a debug mode. Let me kill this up. Start the application again. You can see a lot more logging being printed right now. So a lot of things are being printed, along with which you would actually have a lot of logging about auto configuration, which is printed in here. So this will actually say all the stuff which was auto configured and which was not auto configured. So it's saying dispatcher servlet auto configuration has matched because I found something of this kind in the class path. So it's saying I found a servlet called dispatcher servlet on the class path. So I've configured dispatcher servlet automatically. It's saying I've configured an error MVC auto configuration. I've already configured default error controller. I've configured a cache, generic cache configuration. I've configured Jackson for doing binding. And I've auto configured validation as well. You can also see that there are things like view resolver and everything that were auto configured. Not only that, the auto configuration report also shows what are the things that were not auto configured. So it would show why the rest of the auto configuration things did not match and why they were not executed, why beans for them were not created. Auto configuration is a very, very important concept regarding Spring Boot. One of the most important things to understand is you are still a beginner with Spring Boot, and auto configuration is something which will grow on you as you keep building more and more Spring Boot applications. If the complete concept of auto configuration did not fit in your mind right now, that's not a problem at all. You would definitely learn it by the time you end this course. Auto configuration is one of the fundamental things why Spring Boot is so famous and so easy to use. In this step, we looked at the basics of auto configuration. We looked at some of the beans which were automatically created, and also we looked at where the code for Spring Boot auto configuration is. Until the next step, bye-bye. Until now, we looked at some of the basics of Spring Boot. And before we go any further, I think it would be great if you can clearly separate what are the differences between Spring, Spring MVC, and Spring Boot. I think having great clarity on that would be really wonderful. Spring Boot, Spring MVC, and Spring. How do they compare? That's basically what we would want to answer in this specific step. Actually, by the end of this, you would understand that Spring MVC, and Spring Boot have their own roles. They are not really competing for the same space. They solve really different problems and they solve them really, really well. So what's the core problem that Spring Framework solves? Think about it. The core problem Spring Framework solves is testability. If you don't define proper dependencies, then your applications are not testable. The most important feature is dependency injection. The core of Spring Framework is the IOC, inversion of control. Spring Framework takes control of all the beans and their dependencies. That's basically what the Spring Framework cares about. Spring Framework is all about defining your beans, putting your at component, putting your at service, and things like that, and also defining your dependencies at auto-wired and things like that, and also defining how to find your beans, component scan, for example. That's basically the core problem that Spring Framework solves. Spring Framework solves the problem of dependency injection. It helps you to build loosely coupled applications. Loosely coupled applications can be easily unit tested. If you look at this example, you see that welcome service instance is directly created in here. This is tightly coupled. The welcome controller is now tightly coupled to the welcome service. However, if you do dependency injection properly, then you would auto wire it in. You can use frameworks like Mockito and mock Spring MVC to replace this service with a mock and unit test this controller. That's the main problem that Spring Framework solves. Other than that, Spring Framework also solves a few other problems like duplication. That's basically plumbing code. So if, let's say, you are using JDBC, then you needed to write a lot of boilerplate code, try, catch, exception, and all that kind of stuff. That's not needed when you use any of the things that are based on the Spring Framework, Spring JDBC or Spring JMS. You don't really need to do that kind of stuff at all. The other thing which Spring Framework solved was providing good integration with other frameworks. So Spring had good integration with Hibernate for ORM. IBAT is for object mapping. It has good integration with JUnit and Mockito as well. Spring MVC is concerned with developing web applications. Spring MVC provides simple way of developing web applications. One of the great thing about Spring MVC is the separation of concerns. Dispatcher servlet is concerned with just the basic front controller part. There is a modal and view. There's a view resolver which is concerned just with resolving a view name to the physical view. With these kind of simple concepts, Spring MVC makes it very, very easy to develop your web applications as well as your RESTful services. Whether you are developing web applications or REST services with Spring Boot, internally you are using Spring MVC framework. That's the Spring Web MVC framework. Why do we need Spring Boot? That we have talked a lot about in this specific course. So in the last few steps, we saw the need for Spring Boot, right? We don't want to be configuring things like that. We are configuring view resolver, we are configuring dispatcher servlet. If we are using Hibernate JPA, we need to configure data source, entity manager, and transaction manager, and a lot of that kind of stuff. Spring Boot says, okay, why do you need to do all this configuration? Can we really think different? The thinking of Spring Boot is, okay, this guy has added a Spring MVC jar. So can I configure some of the beans automatically? Can I configure a dispatcher servlet automatically for you? Can I configure a view resolver automatically for you? Can I configure a data source if a Hibernate jar is on the class path? I know he put Hibernate class in the class path because he wants to talk to a database. Why don't I automatically create a data source? So that's what Spring Boot does, the auto configuration part. It looks at frameworks which are available on the class path and provide automatic configuration. These startup projects are all built around well-known patterns. We will talk about Spring Boot Starter Web and Spring Boot Starter JPA in the next step. Other than starters, the important goals of Spring Boot to provide a few monitoring features. So it also provides starters like Spring Boot Starter Actuator, which is used for monitoring. So it enables monitoring for your application. And also it has starters to pick different embedded servlet containers. And it has starters for logging. So if you want to use Log4j, there is a separate logging for it as well. I hope this video helped you to understand the difference between Spring MVC, and Spring Boot. In the next step, we would focus on starters. Welcome back. In this step, we would look at starters. We would look at a couple of example starters, Spring Boot Starter Web and Spring Boot Starter JPA. If you open up the pom.xml of the project that we have created earlier, you would see that it's using Spring Boot Starter Web. How did it use Spring Boot Starter Web? That's because we configured a dependency on web in here. So if I open that up and go to the pom.xml, you would see that the Spring Boot Starter Web is configured in here. So the Spring Boot Starter Web is the preferred starter for Spring Boot to develop web applications as well as RESTful web services. So if I go control and hover over it, or command and hover over it, and click open pom.xml for Spring Boot Starter Web, you would see that it defines varied kind of dependencies. So what does it really define? Let's look at it. When we run the application, we were automatically using Tomcat. That's because of this Spring Boot Starter Tomcat. If you look at Spring Boot Starter Web, it contains a dependency on Spring Boot Starter Tomcat. And that's how the application is automatically running in Tomcat. The other things which you would see in here are Spring Web and Spring Web MVC. Spring MVC, as you would know, is the Spring MVC framework. I add in a Spring Boot Starter Web, I automatically get Spring MVC, I automatically get validation. Validation, the default implementation for Java Validation API is Hibernate Validator. So I get that as well, and I get Tomcat, and also I get the starter JSON. The starter JSON is more for RESTful web services. We saw that when we actually invoked the RESTful web service, the conversion to JSON automatically happened. If you actually looked at our code, we just returned the bean back. So in the books controller, what we are doing is we are just returning a list of beans back. How is it automatically converted to JSON? That's done through the starter. The starter JSON brings in JSON binding into the picture. Basically, when you look at all starter projects, they have a set of dependencies that are already defined. And these dependencies are automatically provided to our project. So when I add in Spring Boot Starter Web, I get all these dependencies. So you'd see that I'm getting Jackson for handling all the JSON stuff. You'd see that I'm getting Tomcat so that I can run the application in Tomcat. I'm getting Hibernate Validator and Validation API for doing the validation. I'm getting the Spring Framework because I have a dependency on Spring Web, and that would have a dependency on Spring Framework. And also I would get the logging frameworks as well, because the logging frameworks are by default defined in the Spring Boot Starter. So Spring Boot Starter is one of the dependencies in Spring Boot Starter Web. So if you open up the pom.xml for it, so this is the default starter. This is where everything inherits from. So any starter that you would use in Spring Boot, it inherits from Spring Boot Starter. And you'd see that this has a dependency on Spring Boot framework. This has a dependency on Spring Boot auto configure. That's how we get auto configuration. This has a dependency on Spring Boot Starter logging. That's how we would get logging. And we have dependency on Spring Core as well. YAML is one of the configuration languages that Spring Boot supports. So we also have Snake YAML in here. Thing about Spring Boot Starter Web is once it brings in all these dependencies, what would kick in? Auto configuration would kick in, because the Spring Web MVC contains dispatcher servlet. So automatically dispatcher servlet would be configured. That's done by the Spring Boot auto configure. That's the auto configuration which we talked about earlier. Spring Boot Starter Web is one of the starters. The other starter you can see in here is Spring Boot Starter Test. Spring Boot Starter Test enables you to write unit tests and integration tests as well. So if I go to the pom.xml in here, you would see that it has a definition on Spring Boot Test. It has a definition on the auto configure for Spring Boot Test, and it has dependencies on JUnit framework, assertj, and also you have Mockito. Mockito is the default mocking framework that comes along with Spring Boot. A combination of assertj and Hamcrest are awesome to write great matchers. And you also have a dependency on the Spring test framework, which is useful in writing unit tests for Spring. So until now, we looked at a couple of starters, which are Spring Boot Starter Web and Spring Boot Starter Test. Other than that, another important starter which is frequently used is Spring Boot Starter JPA. If you know JPA, JPA is kind of the interface for Hibernate. So JPA defines how ORM applications or ORM frameworks should work. ORM is object relational mapping. Let's now add in a dependency on Spring Boot Starter JPA. You would see now that there would be a lot more Maven dependencies which would come in. Actually, it's Spring Boot Starter Data JPA. So now we have Hibernate Core, Hibernate JPA, you have JavaX Transaction API, Hibernate Common Annotations, you have Spring Data JPA, Spring ORM, Spring TX, and a lot of such dependencies come in. That's because of the Spring Boot Starter JPA. So if you open up the pom.xml for Spring Boot Starter JPA, then you would see all the dependencies that are listed down. So this has a dependency on Spring Boot Starter AOP, Starter JDBC, Hibernate, Transaction API, and Spring Data JPA. So all these jars you would get. So as soon as I add in a Spring Boot Starter Data JPA, I would get all these things for free. One of the things you need to remember is if you are a starting programmer or this is the first time you are looking at Spring Boot, a lot of things might be confusing to you, especially because we are referring to so many different terminologies. Spring Boot solves problems for wide variety of frameworks. So there are a lot of terminologies that come into picture when we talk about Spring Boot. So if you're not able to understand any of these terminologies, do not worry at all. Over the course of this course and also over the course of your next few years, you would learn sufficiently enough so that those terminologies become really clear for you. The idea for you is to understand the big picture of what Spring Boot does. Spring Boot is now one of the most popular frameworks to develop microservices. The idea behind the whole set of these steps is to give you a flavor of Spring Boot in a wide variety of scenarios. If you're not able to understand a couple of scenarios, that's not a problem at all. With that disclaimer, let's end this step here, and I'll look forward to see you in the next step. In this step, we would want to look at the various starter projects which are present in Spring Boot. In the last step, we looked at we looked at Spring Boot Starter Test, we looked at Spring Boot Starter Web, and we looked at Spring Boot Starter JPA. We look at other starters which are present in this specific step. This will be a short step, but it would be great for you to understand the different starters that are offered by Spring Boot. One of the important starters that is offered by Spring Boot is Spring Boot Starter Web Services. This is the starter you would need to use when you want to develop SOAP web services. If you understand web services, then there are basically REST services and SOAP services. Actually, the classification is not as simple as that because SOAP web services also can fit into the bracket of REST web services. So if you want to define WSDL and then implement your web service, that's a SOAP web service, right? So if you are developing a SOAP web service, then you can use the starter, Spring Boot Starter Web Service. We already looked at using a RESTful application. What did we use to build? We use Spring Boot Starter Web. Similar to that, even if you want to develop a typical web application, you can use Spring Boot Starter Web. Spring Boot Starter Test, as we looked at in the previous example, is for unit testing and integration testing. Spring Boot Starter Test really makes it easy to write great unit tests and integration tests. If you want to write applications using Spring JDBC, then Spring Boot Starter JDBC is perfect for you. If you're writing RESTful web services and you would want to add HateOS features, HateOS, whichever you'd want to call it. If you want to add those features to your services, then Spring Boot Starter HateOS is the one to go for. All web applications and all RESTful services should be secured. Spring Boot Starter Security is the starter for using Spring Security. You can implement both authentication and authorization, and Spring Boot Starter Security has support for basic authentication as well as OAuth authentication. It also has support for OAuth 2 authentication as well. So whichever one you are using, you can use Spring Boot Starter Security. As we looked at in the previous step, Spring Boot Starter JPA is the option when you want to do JPA. By default, Spring Boot Data JPA uses Hibernate as the ORM framework. If you want to implement caching, then you can go for Spring Boot Starter Cache. It has support for wide range of caching options, including distributed caches like Hazelcast. If you are using Spring Boot Starter Data JPA and you would want to expose your entities as RESTful services, then you can go with Spring Boot Starter Data REST. Spring Boot Starter Data REST makes it very, very easy to expose Spring Boot Data JPA Spring Boot Data JPA entities as RESTful web services. They expose all the typical request methods like get, post, put, and delete. The other starters of Spring Boot are more technical. Spring Boot Starter Actuator, which we'll use it in one of the next steps, is for monitoring, and also you have starters for the embedded servers. We saw that by default we were using Spring Boot Starter Tomcat. So you can also use Spring Boot Starter Undertow or Jetty if you want to use those embedded servlet containers. And also there are starters for logging and Log4j. Spring Boot actually provides a wide variety of starters. Actually going through all of them and understanding them would be taking an effort of a lifetime, I think. Okay, there you go. The idea behind this step was to give you the wide variety of starters that Spring Boot provides. Whenever you have a problem to solve, go ahead and look at if there is a starter to solve your problem. Until the next step, bye-bye. In this step, we will investigate much more about Spring Boot Actuator. How do I use Spring Boot Actuator? Very simple. Just like everything else with Spring Boot, using an actuator is also very, very simple. All that I need to do is go to pond.xml, and you have guessed it right. So I just need to add a starter for actuator. So I'm copying the starter for web and changing the starter name to actuator. That's it. It's as simple as that. So I've added in the starter for actuator. So what does the actuator bring in? Actuator actually brings in a lot of monitoring around your application. So in Actuator, you'd be able to read a lot of metadata about the application. Let's say you want to see what are the beans that are configured. You want to see how auto configuration has worked. You want to see how many times a specific service is called. You want to see how many times a specific service has failed. All that kind of stuff you can check in your actuator, and all that I need to do to enable that is add in something called an actuator in. Spring Boot Starter Actuator actually exposes a lot of REST services, and these REST services are compliant with a standard called HAL standard, and we would use a HAL browser so that we can browse through the data which is provided by these services. Dependency for HAL browser, it's Spring Data REST HAL browser. So it's Spring Data REST HAL browser. So you can save the project. The group ID should actually be data. It's all Spring Framework data, Spring Data REST HAL browser. So once we add the dependency for that, the HAL browser would be configured among our dependencies. Now you can see all the dependencies in the Maven dependencies: Spring Boot Starter Actuator, Spring Boot Actuator, Spring Data REST HAL browser. That's cool. Now let's go ahead and start the server. If you look through the log now, you would see a lot of URLs starting with /application. So application info, metrics, dump, beans, env, config properties, audit events, heap dump, loggers, trace, health, mappings, and autoconfig. These are all the URLs which are exposed by the actuator. So actuator provides more metadata about your application. So let's look at these right now. All that I need to do is go to the URL localhost 8080/application, and this is too much zoomed in. Let's zoom out a little. Okay, now this is cool. So this is the HAL browser for the actuator, and you can see the response in here. You can, by default, the Response contains all the URLs that are exposed by the actuator. So let's look at each one of them one by one. So let's look at info. So info is in here. So if I do a get request to info, I can see all the information which is coming out, which is not a lot. So let's go to the next one, which is metrics. One of the things that we are seeing right now is when I go to metrics, it says full authentication is required to access this resource. So it's saying I would need to be authenticated to be able to use this resource. To make it easy for us to invoke them, I'll turn off authentication. This is not something I would recommend you to do in your production, but just to get started, let's turn off authentication. For the way we can do that is by going to application.properties and add in management.security.enabled is equal to false. Save this and restart. We went to localhost 8080/application. Let's go there, and now you can see more information. Beans to start off with, and these are basically all the beans which were mapped. So you can see all the information about which are the beans which are created, what is the scope of the bean, what is the type of the bean, and which class was used to create the bean, and all that kind of stuff. So you can see all information about the beans that are created. Dump would give you a thread dump of the different threads that are running. Heap dump would show you the heap dump details if you would want to see what's happening in memory. The auto config, on the other hand, shows you a debug of the auto configuration. It would actually show you the positive matches, so which of the auto configuration classes were matched and which are not really matched. So you will have positive matches and also negative matches, and it would have a message on why that particular configuration was not done, what did not happen. You have other stuff like configuration properties. This would show you actually all the configuration properties that are available for you. As we discussed earlier, all application configuration can be configured through application.properties. So this config props actually shows you all the properties which are available that can be configured through application.properties. Trace shows you the details for a few requests. For the last few requests, what has really happened, that's what trace would show. This will be useful in debugging problems. env is useful in getting the details about the environment. What operating system are you running on? What version of Java are you using? Where is Java installed? Where is the virtual machine present? And all such information. What is the class path that is being used? All that kind of information is present in the env. Metric shows different metrics about it will show metrics about system in which the application is running. So it shows heap, it shows memory, free memory, it shows the threads, how many classes are loaded, and all that kind of stuff. And also it shows how many times a specific URL is invoked. We actually call these URLs multiple times. We call metrics 3 times, health 2 times, and all that kind of stuff. I'll show you an example. For example, we have the localhost 8080 and the URL is books. So let's invoke that. So now we have invoked books as well. So if you refresh this, you'd see that now books has a count of 1. So you can see that books is called, and books was successfully called with the status of 200 one time. If you now call it again, you'd see that books is called twice. So you can actually keep track of how many times a particular service call is successful. The other thing is it would also keep track of failures. So let's say instead of 200, probably the status is error status. Then you can see here also that that particular service has errored out so many times. This will be useful in debugging problems. You can see which services are erroring out and try figuring out why they are erroring out looking at the trace. Loggers shows the logging configuration for various classes. Health shows the status of the application, whether it's up and running or not. So it shows the status, how much disk space is free, and all that kind of stuff. The mappings shows all the URLs that are mapped in the application. So it shows /books, /error. /error is the default error handling that Spring Boot provides through auto configuration. And all the application URLs that we are looking at, application beans, application audit events, dump, heap dump, auto config, config props, and so on and so forth. So Spring Boot Actuator provides you a lot of stuff which helps you in monitoring this application. One of the important things with all this monitoring information is this has to be secured. So Spring Boot automatically turns authentication on for the admin modules. This is called the management modules. In this step, we added our dependency on Spring Boot Actuator and HAL browser, and we use them to browse through all the APIs which are offered by Spring Boot Actuator. Until the next step, bye-bye. In this step, let's look at my favorite feature. The application is up and running, and I'm making a change here. So I'm changing the mastering Spring 5.0 to 5.1. What would happen when I execute the service? The service is still returning 5.0. The service does not pick the change up because to pick up the change, I would need to stop the server and restart it again. And that's cumbersome, isn't it? Starting up the server would take a few steps. It would take a few seconds, and that would waste my time. How can I get the whole thing to be loaded automatically as soon as I make a code change? How do I do that? That's where Spring Boot developer tools come in. It's an awesome dependency. I love it. So I'll copy Spring Boot starter actuator and I'll put it below test. Spring Boot, it's called Spring Boot Dev Tools. I just added a dependency onto Spring Boot Dev Tools. It's as simple as that. I'll wait the whole thing to build. So you can see that it's downloading that dependencies. The project is ready, and now I execute it. When I start the server, you can see that the server is loaded, or the server is started, and now I execute it. I would get 5.1 obviously, right? Because I've restarted the server. But the great thing from now on is any Java changes that you make would be automatically picked up. So I'm going back to 5.0. What would happen if I execute this? One of the things you would see in the log is that the application is restarting automatically, and 5.0. This time, let's focus on what's happening in the log. I'll just clear off whatever log is there, and I'm making a change. Mastering Spring 5.1, let's say. 5.1 is not yet here at the time of creating this video, but just having fun. So you can see that this specific thing is also very efficient at the way it restarts. You can see that this actually started in 2 seconds. The change was picked up in 2 seconds. I'll stop the application and restart it. You'd see that actually the typical restart when I do a fresh restart on Spring Boot is about 8 to 10 seconds. So this is taking about 9 seconds. So if I stop and restart the application, it's taking about 9 seconds. However, if I just make a change directly here, what I'll do is I'll actually turn this off, and also is look at how much time it takes. So now how much time did it take? You can see that this actually takes 2.5 seconds. Pretty cool, isn't it? So one of the things that Spring Boot DevTools does very effectively is it knows that everything in the Maven dependencies will not change at all. So it will not load things which are dependent on these again. It will only load those beans which are the application beans again. That's why it takes lesser time when you make a change. When you restart the server, everything including whatever is in here is loaded. But when you make a change in the application, only that specific things which are application related are reloaded again. And that's the reason why you see that it only takes 2 seconds. And imagine the amount of productivity you would gain with this. So this is almost 10 seconds saved for every change you make. If you are maintaining any kind of application, that's a big productivity boost. So if you are using a Spring Boot application, and if you are not using Spring Boot developer tools, then go ahead and try it. That's a pretty cool addition, I would think, to Spring Boot. In this step, we looked at Spring Boot Dev Tools, which is one of my favorite additions to Spring Boot. Until the next video, bye-bye.
Welcome to this section titled The Journey from Spring JDBC to JPA. In this section, we would take a quick look at the world before JPA, the world of JDBC, where we used to write a lot of queries. We'll create a simple example using Spring JDBC and migrate it to JPA. We would learn the basics of JPA, entities, and repositories. We would create a simple JPA repository to perform a few simple CRUD operations. The home folder for this specific section is on our GitHub repository JPA with Hibernate, and you have to go into the 01 from JDBC to JPA. So this is the folder. Once you go into that specific folder, you can see the details of all the steps, the notes which we have used during this section, and the complete code example as it is at the end of this section. There are also a few intermediate backups at different stages of this section. This section will help you to understand and appreciate the magic of JPA. I would recommend you to complete this section before moving into the advanced section of JPA. I will see you in the first step.
Welcome back. In the first step, we will set up a simple project for JDBC. So let's get started. As usual, we would go to start.spring.io. That's the best place to set up your project. I'll choose Maven, Java, and I would use Spring Boot 2.0.0.0 M3. If you have a later version of 2.0.0, go ahead and use that. For now, the latest one is M3, so that's pretty cool. Group ID I would be using is com in 28 minutes JDBC, or I would call this database. Com in 28 minutes database is good, and I would call this database demo. As far as the dependencies are concerned, the dependencies we would be using are starting with JDBC. So we are trying to learn JDBC, so that's what I would want to add. And the other thing I would want to learn is JPA. So after JDBC, we would go into JPA. We'll develop the application with JDBC first, and then we'll also use JPA to develop the same application. So we need JPA, and we are going to use an in-memory database called H2. H2 is an in-memory database. That basically means for using H2, you don't really need to set up anything. It's a very, very easy database to use. If you are interested to migrate to something like MySQL, we'll discuss that a little later. For now, let's focus on H2 as the in-memory database. Other than that, we would want to look at H2 in something called a web console. So H2 offers a client, and we can use a web console to look at the data which is present in H2. So I would add in web. So the dependencies which we are adding in are JDBC, JPA, H2, and web. Make sure that you have all these 4 dependencies added in. The other important things are to use the latest version of Spring Boot, and make sure that you're using Maven project with Java, and the group ID com in 28 minutes database, and the artifact ID database demo. You can click generate project. This would download a zip file. As usual, extract this zip file to some folder on your local machine, and let's import that into Eclipse. Now I can import the Maven project from the folder where we extracted the zip file to by using file, import existing Maven projects. Just type in existing and you would see existing Maven projects in here. Next, and the directory where I copied it to is 04 Spring JDBC to JPA. That's the directory where I copied it to. You can put the path of the folder where you have your zip file and zip to, or you can use the browse button to navigate to that folder. Now let's go ahead and say finish. This might take a little while if this is the first time you are doing something with Maven. If this is the first time you are actually importing a Spring Boot project with Maven, or if this is the first time you're using that specific version of Spring Boot. At the end of the import, you should see a simple thing like this. So you'd see a database demo application, which is a Spring Boot application, which will help us to launch all the stuff we will write. And you should see a application.properties, which we can configure. This is Spring Boot application.properties, and you would have a source test Java. And other than that, you would see in the Maven dependencies that there are a lot of stuff which are coming in, because we have selected a lot of starters. So if I open up the pom.xml, you'd see that the group ID is in 28 minutes database. The artifact ID is database demo. Where are they coming from? This is what we configured in here, right? Com in 28 minutes database demo. That's where they are coming in from. Other than that, you'd see that the version which we are using is 2.00M3. That's coming from here. And the dependencies which we have added in are JPA, JDBC, web, and H2. That's pretty cool, isn't it? What we'll do before we end this step is run the database demo application. So right click, run as Java application. This would launch up a simple web application. We did not really write anything yet, but I'm just trying to make sure that everything is working fine. So let's run that and see that everything is set up and working fine. This might take a little while because it searches through all the files for main classes. I have no idea why it does that. Let's wait for a little while, wait for it to complete the whole indexing stuff, and you'd see that it would launch that as a Java application very soon. Finally, it's launching up, and you'd see that the Spring Boot has launched up. It has taken about 10 seconds, not bad. And you'd see that Tomcat is now started on 8080. Tomcat is the default embedded server with Spring Boot. If you want to kill this application, you can just click this red button in here. So this would kill the application. This is a web application, so you should need to start and stop it by killing the kill button. So in this step, we set up a simple application. We did not really do anything fancy yet. All that we did was we went to Spring Initializer, we chose JDBC, JPA, H2, and web as the dependencies. We were able to create a simple project, imported it into Eclipse, we ran it as a Java application, and we saw that the application was launched up in Tomcat. Until the next step, bye-bye. Welcome back. In the last step, we set up a simple project. In this step, what we want to do is we would want to be able to connect to our in-memory database H2. We would want to be able to see if we are able to play with it and learn more about the H2 in-memory database. What we did until now for H2 is basically we added in a H2 as dependency in the pom.xml. One of the things which we talked about in the introduction to Spring Boot was the fact that Spring Boot has this feature called auto configuration. This auto configuration looks at the fact that H2 is one of the dependencies available, and it will automatically configure a connection to the H2 database. So it would automatically configure a data source which is connecting to the H2 database. What we want to be able to do is to connect to the H2 database. I would want to be able to see what are the tables which are present in there, what is the data which is present in there, and all that kind of stuff. In this step, let's focus on just trying to connect and see the fact that there is no tables which are present in there. So let's get started. The way we can configure it is by application.properties. In application.properties, you can say spring.h2.console.enable is equal to true. This would enable something called a H2 console. So you can stop the application and start it again. You can see that there is now a new web servlet which is mapped to /H2 console. So now let's see what's happening with H2 console. I'll go to localhost 8080/H2 console. So the URL again is localhost 8080/H2-console. Just type that into your browser and this is what would come up. Make sure that you're choosing the right drop-down value. So we are connecting to a H2 embedded database. You can give any name to this setting and you can save it if you'd want to. And the driver we are using is org H2 driver, and the JDBC URL is jdbc:/H2:mem:/testdb. That's the defaults that we are making use of. So make sure that you have these right values present. We'll use a username SA and empty password, and you can click connect. This would launch up the H2 console. This is very similar to any other database client that you would be using. For example, if you're using a MySQL, you'd be using a MySQL client to connect to it and execute queries on the database. If you're using Oracle, you might be using something like Toad or SQL Developer. So This is similar to that, except for the fact that this is on the web. So we are using a URL to navigate to that. As of now, there are no tables in this particular database because we have not created any tables as of now. What we want to be able to do is we would want to be able to create a table and populate some data into this in-memory database. The thing about in-memory database is this is only live as long as the application is running. As soon as the application stops running, this database gets killed. The thing about in-memory database is the fact that it's so easy to maintain. You would see that in the next steps, we would add data to it, and we would see that it's very easy to start this up, connect to it, and do all the things around that. If we really connect to a database like Oracle or MySQL, you would see that there is a lot of setup that is needed. You have to install the server, you have to create a database, you have to define the schema, populate the data, and if by mistake some of the data is getting changed, you need to initialize it each time. There's a lot of setup that is involved with creating an actual database. In-memory database is an awesome tool for learning stuff. Once you complete your learning, you can easily connect to a database of your choice, a MySQL or an Oracle. With Spring Boot, all that you need to do to connect to a new database is to change 3 or 4 property file values. That's it, and you'd be ready to connect to other databases. In this course, what we'll do is we'll start with connecting to a H2 console, and at the end of this section, I'll show you how you can connect to a database of your choice. In this short video, we introduced you to the H2 console. We helped you to launch H2 console. We saw that there are no tables present in here and there is no data in there. In the next step, what we'll do is we'll try and create a table and initialize some data in there. Until the next step, bye-bye. Welcome back. In this step, we'll try and create a simple database table and we'll see if we can see the data in the H2 console. We have already added in JPA, JDBC, and also H2 as dependencies in our pom.xml. So we get a feature through auto configuration. That's basically that you can define in the source main resources, you can define a SQL file. So I can create a SQL file with the name data.sql. If you create a data.sql file in the source main resources, when you launch up the application, this gets called. All the data in the data.sql is used to initialize the database. So we'll use that feature. This is one of the auto configuration features that is provided by Spring Boot. So we'll make use of that to add some data to our database. So we'll first create a table and then add some data to the database. What we want to do is we want to create a person table with a few columns. I would want to create a column called ID, and I would want to give a name to the person. I would want to give him a location. So a name, a location, and also let's say I would want to track his birth date, birth_date. Let's say this is the table I would want to be able to create. So person table with all these columns present. Now, how do I create a table? Create table person. So this is normal SQL, right? So this is data definition language to define a table. So we would want to create a table called person. So create table person. Inside that, I would want to have a column called ID. To create a column, what I would need to define is its type. ID, I would want to have it as an integer. And because it's a primary key, I don't want to have a null value in there. So I'm saying not null. Next, I would want to define my name. The name, I would have varchar of 255 characters. And I can say not null for this as well. I don't want name to be null at all. And location, varchar of 255, it can possibly be null. So I'll leave it as it is. And for birth date, I would use a timestamp. I would want to be able to hold a date and a time. So I'm using something called a timestamp. In addition to this, I would want to declare the fact that the ID is a primary key. Now, just save this down. I put a semicolon down here. Be very careful with the syntax. Everything here should be exactly as what I have typed in here. So you need to have a open bracket, a close bracket, a semicolon, and all the columns separated by commas. There should not be any comma after the primary key ID. So make sure that you are exactly typing it in as it is in here. Let's now stop the application and start it again. I'm searching if the create, oops, I don't see it here, but let's go to the H2 console and see if I can see it down there. So let's refresh, continue please. I would need to connect to the database again. And now you see a table called person. And when I do a select star from person, I can see no data which is present in here. But the important thing for us is the fact that there is a table called person which is present. ID, name, location, birth date. Now we have created a table in the database with a few columns which are present in there. In this small step, we created a table in the database. In the next step, we would populate some data into it. Until the next step, bye-bye. Welcome back. In the last step, we created a database table. Now, we would want to populate some data into that table. I'll go to the H2 console, refresh it. That's cool. Connect. And when I do a select star from person, I see no data in here. So what I would want to do is I would want to be able to insert data into person. So we need to write a insert query. So I would need to write a query called insert into person. So I'm going to insert into person, and over here I would want to be safe. So I'll define all the column values which are present in here. So I would want to insert into person ID, comma name, comma location, comma birth date. So I'm defining the columns, and then I would want to define the values that I would want to insert. So the values that I would want to insert are, let's say the ID, I would want to have it 10,001. So make sure that you're using a big ID value, because at a later point in time we will use JPA and we'll auto generate these IDs, and we don't want there to be a conflict. So make sure that you're having a big value, 10,001. That's cool. And the name of the person, I'll give it as Ranga. Make sure you're using single quote and not double quotes. So use single quotes. And the location of Ranga, I'd put it at Hyderabad. That's where I am right now and recording it from now. The birth date, I'll take the easy shortcut. So I'll say birth date is sysdate. Sysdate is one of the functions. It gives you the current date and time. Now this is the typical syntax. Make sure that you are exactly typing as it is. The values might be a little different, but the structure of the query should be exactly as it is, and run it. So now you can see that insert into person, update count 1 and 20 milliseconds. That's what you're seeing in here. So let's copy the query. So it's executing fine. And let's see if this data is inserted into the table. How do I do that? I can do a select star from person. Make sure you are selecting that and running run selected. I don't want to delete the insert query. I would want to use it for another purpose. So I'll leave it there. I'll say run selected. Now the select star from person is getting one row from the database. So I can see one row which is coming out of the database. ID, name, location, birth date. You can see all the details are right as well. So that's pretty cool. So I'm copying the query and I'm taking a backup of that query. I've restarted the application now. I'm going back to the H2 console. Now I'm going to run a select star from person. Aha, no rows present. The thing about in-memory database is whatever data you insert, when you restart the application, all that data is lost. So whatever changes you make to the data, they're all lost when you restart the application. It's an advantage as well as a disadvantage. For now, what we'll do is a simple thing to counter that. What we have done is we have taken a backup of the query. So one of the options is I can keep running this query here again and again and again at the start of the application to populate some data. But that's a manual thing. I hate manual stuff. Let's automate it. How do we automate it? Think about it. We already used a specific option to create the table. Why don't we use the same thing to populate some data in as well? Let's do that right now. So what I'll do is in the data.sql, I can create some more queries. these are the values. So I'll not just insert one person, I will insert 3 persons. So 1002, let's say James, and let's say this guy lives in New York, and 1003, and let's say this guy is Peter from Amsterdam. Make sure that you are having different IDs. ID is a primary key, so you need to have different values for the ID. I'm using 10,001, 10,002, 10,003, and let's stop the server and start it again. The reason I copied the query from whatever we have run in H2 console is because it makes sure that there are no mistakes. So let's go ahead and run this application again. Let's launch up H2 console again. You'd see person, and when I do a select star from person, you see 3 rows. So this is kind of the initial data that we'd be using for our JDBC section. So we now have a table, we have some initial data to play with. What we'll do is we will start using that data to query and put information out. In the next few steps, we will really start with playing around with JDBC. In the last few steps, what we have done is we initialized our database, we created a table, we created some data into our table, and now we would start playing with JDBC. Until the next step, bye-bye. Welcome back. In the previous step, we populated some data into our table person. In this step, we will start with writing our Spring JDBC stuff. This is stuff you're looking forward to from a long time, isn't it? Let's get started with it right now. So let's create a new class as usual. So I'll call this new class, and what we would want to do is we would want to get the details of person. So there's a person DAO, and I would at a later point use JPA to get the same detail. So I'll call this person JDBC DAO. So, and I'll use the package database demo.jdbc. So the package is .jdbc, the name of the class is person JDBC DAO, and let's say finish. Now we have a simple class person JDBC DAO. What does this do? This talks to the database, gets values from there. What should I use? Repository. Repository is the right one. I could have called this component. It would not make any difference as far as this specific example goes, but it's always good to use the right annotation, and the right annotation in this specific situation is at repository. It talks to the database, so it's a repository. Now over here, I would want to create a simple method. I would want to be able to get the details of all the to-dos. So I would want to do a select star from that table. So what I would want to do is I would want to do a select star from person table. I would want to do a select star from person, and I would want to be able to return all the values of person. I would want to be able to print the values of the person. So how do I write a query for that? So the return type would be list of person. So that's cool, and I would want to call this method find all, and inside the method we would want to be able to talk to the database. So how do we talk to the database? Typically, if you're using normal JDBC, you would use a database connection. So you would create a connection to the database and use it. But we are using Spring, so we would want Spring to give the database connection to us. How do we do that? The way we can do that is use something called JDBC template. If you're using Spring, then you have to use JDBC template to execute a query. So JDBC template, I'll do an import JDBC template, and I would want Spring to auto-wire it in. I'll auto-wire a JDBC template. We'll talk a little bit more about JDBC template a little later. For now, let's get the example running. So JDBC template dot, I'd want to execute a query, right? So I would want to execute a query, and the query I would want to execute is select star from person. And where do I want to map it to? The person bean. Thing is, we have not really defined a person bean yet, right? So let's go ahead and quickly define a person bean with exactly the same names as we created the table. So I'll say control 1, create class person. I would want to use a different package. So I'll say database demo.bean, or you might even call this entity. When we talk about JPA, you will understand what an entity is. But for now, let's not really worry about it. So the fields I would want in here are private int ID. That's the ID field. The other one I would want is private string name, private string location, and we have private date, birth date. Input the java.util.date. Let's also create a few constructors so that it's very easy for us to do stuff. So right click source generate constructor and choose all the fields. And I'll also create the getters and setters for these fields as well. So the same thing, right click source generate getters and setters, select all and create it out. So we now have a person bean which is present, and now I can use the person bean in here. So the person bean is now available in here. Oops, what's the problem? Okay, this is cool. Now I would need to now map whatever data is coming from here to the person bean. When the query is executed, you get something called a result set back. From that result set, I would need to map it to the person. How do I do that? In Spring, in Spring JDBC actually, there is a mapper. There is an automatic mapper which can be used when the column names match. So this ID maps to the ID field in the database, name maps to name, location maps to location, and birth date maps to birth underscore date. So this is exact mapping. So we don't really need to define a row mapper or something like that. We'll look at what is a row mapper and other stuff a little later. For now, we would use the default row mapper, which is provided by Spring. It's called bean property row mapper. Control space. I would want to import it in, and the bean is person.class, and I would want to return this back. Let's organize the code a little bit better. This is clean, I guess. Now I can see all the code in my screen. Oops, this is not fine. I'll just need to press and enter. Okay, this is cool. I can see that I'm getting the select start from person. I'm using a row mapper. In this step, what we did was we created a simple repository, person JDBC DAO. We used JDBC template to fire a query. We are using a bean property row mapper on the person class to map the results out, and we are returning a list of person back. In the next step, we will execute this query and see if it's working fine. Until then, bye-bye. Welcome back. In the previous step, we created a person JDBC DAO, and we defined a simple find all method in here. We are using the JDBC template to fire a query against the database, and we use the bean property row mapper to map the person class for it. That's cool. Now we would want to be able to fire this at the startup of the application. So what we'll do is, in the database demo application, we'll implement a command line runner. So command line runner is one of the interfaces which is present in Spring Boot. This would be launching up. When I implement a command line runner, then this code which we write in a specific method, that would be launched up as soon as the application context is ready. So when the Spring application context launches up, the code in the command line runner gets executed. So let's do that. So I'm implementing command line runner. I'm importing it in. You can see that it's an org spring framework.boot. So it's present in the Spring Boot framework. And now I would say add unimplemented methods. So I just went here, press Control+1, and it would add the methods in command line runner which are not implemented. So if you go to the command line runner, you would see that there is only one method which is present in here, run. So I would need to implement that in here. So I'd go ahead and implement it right now. And over here, what I would want to do is to fire a query. How do I fire a query? What do I need to use to talk to the database? We use the person JDBC DAO. So person JDBC DAO. And this would be a DAO. And who would get this for us? Spring would get it for us and auto wire it in. So I'll say at auto wired import, please change to that. That's cool. And now I can use the DAO to fire a query. So DAO dot find all. This will return the list of values back. So I would want to print that to the console. I would need a logger. So let's define a logger. Private logger is equal to logger factory dot get logger for this specific class. And let's organize the imports. I would want to use the SLF for J1, and now I can say logger.info. I'll log this at info level, and I would say all users, and I would want to print the value in here of the DAO.find all. What does the logger do? It takes this value and replaces the first occurrence of this variable template. So let's format the code a little bit. Stop and start the application. Let's see what would happen. I would expect an exception to be thrown. Why is it so? Let's find out. Okay, there is a exception that is being thrown, and if you look at it, it says no such method exception, and it says person.init empty. So actually, whenever I'm using a bean row mapper, so what we are using in the JDBC is a bean property row mapper. And whenever I use a bean property row mapper, the bean on which the bean property row mapper is defined should have a no argument constructor. So I need to create a simple no argument constructor. One of the things is this is the default one which is provided by Java. So if this constructor was not there, this is provided by default, so I don't need to provide this at all. But since we provided this constructor, Java would no longer provide the default no argument constructor. So I need to provide that right now. So I'm just initializing a default no argument constructor and restart the application again. Actually, start the application because last time the start failed. Let's see what would happen now. The application started up, and when I look at whatever is printed, it says all users, and it's printing the person hash code stuff. So there are 3 persons printed, but it's printing the hash codes of it. How can I avoid that? I'd want to see the real values of person. I hate the hash code stuff. How do I do that? All that I need to do is generate the toString. So again, right click source, generate toString, and I would want to include all the fields. That's fine. Go ahead and do that, please. So this would generate a person, but each person I would want to actually print it in a new line. So I'll say /n. This would make sure that the details are printed on a new line and it's easily more visible in the log. Now let's stop and restart the application. Okay, this is the reason I had a /n, because I don't need to scroll anymore. So all the new persons are printed on new line. So you can see all the details that are populated for the person. You can see that the data is retrieved from the database. I'm able to see the data which is present in here. So in this step, what we have done is we were able to use the find all method inside our DAO to query for all the persons, and we printed the values that we loaded in for person in the log. That's cool. That's your first JDBC stuff working. So what we did in this example is we used Spring JDBC to execute a query and print the results of that query. We'll do a lot more in the subsequent steps. Until then, bye-bye. Welcome back. In the previous step, we created and executed the find all method. We were able to print all the details of a person. We saw how easy it is to write a simple method with Spring JDBC. This JDBC template is something which is implemented in Spring JDBC. You can see that it's part of org Spring Framework JDBC core. How did we do this kind of stuff in JDBC? It was very, very complex. In this step, let's compare JDBC with Spring JDBC and understand how Spring JDBC makes it very easy. So what you're looking at on your screen right now is a simple JDBC example for doing a similar exercise. Instead of the retrieve persons, here it is retrieve to-dos. So this one is using JDBC. In JDBC, what we needed to do was first we needed to get a connection, then we needed to create a prepared statement, you need to execute the query, and then we needed to get the values individually out of the result set, and add it to the list, close everything out, and return the to-dos. One of the problems which is not handled very well in this piece of code is exception handling. Because if, let's say, some piece of code here fires an exception, then the statement and the connection will not get closed and there will be leak of a connection. So you will lose a connection. And that's not really good. So if I really implement that well, then this code becomes even more complex. This is how typically things are done in JDBC. And Spring JDBC provides an easier option than that. Let's consider the advantages of Spring JDBC. One is less amount of code. Instead of writing 100 lines, you would be writing 5 or 10 lines of code. So that's number one. Number two, it also prevents you from making mistakes, because what we will do there is we don't really need to handle the connection statement and things like that. And even if there is an exception happening, the JDBC template makes sure that the connection is closed. So the number of chances that you make a mistake are reduced when you use Spring JDBC. So those are the two main advantages with respect to Spring JDBC. In this step, we took a quick look at JDBC, some example JDBC code, and compared it with how things are done with Spring JDBC. Until the next step, bye-bye. Welcome back. In the previous steps, we were able to query the data from the database and print it on the log. The thing which we made use of was JDBC template. But one question we didn't answer earlier was, how is the JDBC template getting auto-wired in? How is it knowing about the connection to the in-memory database? Where is the data source? And all that kind of stuff. In this short video, we would try and give you more information about how the whole thing is happening. The entire magic is due to Spring Boot auto configuration. If you go to your application.properties, it's in source main resources, application.properties, and you can type in logging.level.root. So I'm setting the root logging level of the application to debug and restart the entire app. So start and stop the application. Once you do that, you can search in your log for configuration report. So I'm searching for auto space configuration or configuration report. So this is basically what I'm looking for. When you run the application in debug mode, you'd see a complete report of auto configuration. Auto configuration, as we discussed during Spring Boot section, is a very important feature which is present in Spring Boot. What Spring Boot does is it looks at what our classes are available on the class path, and it would automatically configure things based on that. If it sees an in-memory database like H2 on the class path, what it does, it automatically configures a connection to it. If it sees a web application on the class path, what does it do? It configures a dispatcher servlet. If Spring Boot sees JPA on the class path, it would automatically configure an entity manager factory and a transaction manager. What I would recommend you to do is to look through this auto configuration report. You'd see a lot of information which is present in here. It also prints what did not match, what it wanted to try to auto configure, but it will also show you what did not really match. These are called negative matches. I would recommend you to put the application in debug mode, run it, look at the auto configuration report, and you would get much more understanding of what's happening in the background. What I've done is I have extracted some of the important stuff which is happening, and I've put it on our GitHub page for this section. If you go to the bottom of this specific page, below the code example, you would see a little bit of notes on the auto configuration which is related to JDBC template. What is happening here? We already looked at H2 console. The H2 console auto configuration is matching. It was configured. Why was it configured? Because it was looking for a web servlet. Once a web servlet class is present, then it would try and auto configure H2. There are other conditions as well. The other condition is to have this property in the property file. When we were enabling H2 console, if you remembered it well, then you would remember that we configured this property in application.properties. So at the top of application properties, we have this Spring H2 console enabled is equal to true. H2 console is only auto configured when there is a class called web servlet, when H2 is in the class path, and when it's enabled. So only when the conditions are matching, the H2 console is auto configured. Similar to that, the data source auto configuration. So the data source is auto configured when there is a data source or a embedded database in the class path. We have a embedded database H2. So the data source is auto configured, and using the data source, a JDBC template is auto configured as well. So what happens in the background is, because there's a embedded database in the class path, a data source gets auto configured, and also a JDBC template using that data source gets auto configured. This is all the magic which is happening in the background. If this is the first time you're looking at auto configuration, this might be a little confusing, but don't worry about it. As you play around with Spring Boot, you will be understanding auto configuration a lot more, and you'll be able to figure out what's happening in the background. In this step, we took a small break from all our hands-on stuff and looked at what's happening in the background with auto configuration. We looked at how a JDBC template is being auto configured. Until the next step, bye-bye. Welcome back. In this step, we'll get our hands dirty and we'll write a query to get the details of a specific person. So we want to pass in the ID and get the details of a specific person. So how do we do that? Let's look at it. So I'm copying the previous method. I'll call this method as find by ID. And I would pass in the ID of the person. So the ID of the person is integer, right? So it's int ID. That's the one which you would want to pass in. And over here in JDBC template, when you are querying for a single person, so I'm now not querying for a list of persons, but I'm querying for a single person. In these kind of situations, you can use something called query for object. So query for object is when you are actually querying for a specific object, when for a specific thing. So what we want to do is we would want to query this select start from person for a specific person. So I would want to say where ID is equal to question mark. So now I would need to replace this question mark with the ID which is passed in. So select start from person where ID is equal to 1 when ID is 1. When I is equal to 3, the question mark should be replaced by 3. How do I do that? The query for object method accepts a list of parameters. So I would need to create an array of objects and pass the parameter ID in. So this query might be having multiple parameters. In that case, you can pass multiple parameters in. But for now, we only have one parameter that needs to be passed. So I'll say new object of ID. Let's pull it down a little bit so that it's much more clearer to understand. So this is what we have until now. Now I would use the same bean row mapper which we defined earlier. And what I'll do is change this. So it's no longer a list of person, it's just a person. Very simple, isn't it? Find by ID and specific thing. And I'll go to the database demo application and say user ID 10,001. So let's make sure we have that in the data.sql. Yep, 10,001 we have inserted. So let's get the details of 10,001. I need to say find by ID and pass in 10,001. Let's try to print this right now. Let's run this. The application is in debug mode. I would rather stop this, remove the debug mode so that I can see the log much more clearly. I'll go to my application.properties. I would comment this one by putting a hash in front of it and start it again. Over here, you can see user ID 10,001. What we looked at in this step is to retrieve the details of a specific ID. As an exercise, what I would recommend you to do is to create similar queries. So for now, we are trying to find by ID. When you find by ID, there will be only one row back. But you can create other methods for find by name. For find by name, you can have multiple results. back because there can be multiple persons with the same name. And also you can do find by location. So I would recommend you to try and play around with the data and create a few more methods in here. You can try to create a few more retrieve methods, trying to write queries for them and trying to retrieve the data for them. And then you can call them from the database demo application from the run method to check if they are all working fine. I'll see you in the next step after you complete those exercises. Until then, bye-bye. Welcome back. In this step, let's write a simple query to delete by ID. So it should be very simple to do that. I'm just copying the find by ID. Now what we want to do is not find by ID, but delete by ID. So I would want to delete the user who has a specific ID. Now instead of the query for object, what we would use is a method which is present called update. So remember, whenever you want to execute a query to do some update, you use the update method on the JDBC template. Whether the update is a update or a delete, irrespective of that, we would be using the update method which is present in the JDBC template. And the query is delete from person where ID is equal to question mark. That's cool. And I don't need the mapper because I don't really need to map anything in here. The thing is, delete by ID returns a number back. If I go to the update method, you'd see that it returns a int back. If you go further up, you'd see that it actually prints how many rows were affected. So it returns out how many rows are affected by the query. So I'll return that back. So I'll change the return type to int. So this would return how many rows were deleted. That's cool. So now I'll go here and I would now execute it. Now I would want to delete not 1001, let's delete 1002, 10,002 actually. And I would say deleting 10,002. Number of rows deleted is this. And over here, we would want to say not find, but delete by ID. Okay, now I can stop and start the application and see what would happen. Over here, you can see that deleting 10,002 and number of rows deleted is 1 because we are expecting one row to be deleted there. And we can even go to the H2 console to make sure that we have the right thing present. So I'll go to localhost 8080 H2 console. I'll do a connect and run. So you can see that 10,002 is no longer present in the database. It's been deleted because we have executed the delete query as part of our launch. So here we are deleting the ID 10,002 and the row is completely deleted. In this step, we wrote the delete method by ID. I would recommend you to play around with the deletes. So try and delete different persons by different characteristics by passing different parameters in. You can even have multiple parameters passed in. So I can say XYZ is equal to something and pass in the value for that in here. So ID comma whatever value you'd want to pass in. So that's how you would add additional parameters to the query. Actually, I cannot say comma, where, and or whichever SQL thing that you would want to make use of. So try that and I'll see you in the next step. Welcome back. In the previous steps, we created simple methods to find, to delete, and do different stuff with your person. Now, in this step, we'll start with creating an insert method, and then we would move on to an update method as well. So let's get started with the insert method. It's not going to be delete by ID, it would be insert. The input to this method is going to be the person object. I would want to insert a person. And over here, query I would need to execute is going to be the same query that we used in the data.sql, except that the values will be a little different. You would need to set the values that you would want to use. So I need to use this. So I'll copy it in. Instead of the values, I would need to pass in question mark. I'll remove the semicolon and then you have your query ready. So this is the query we would want to fire. One of the things is when we write the queries, it's better to use all small. So insert into person, I would say ID, name, location, birth underscore date. Explicitly providing the columns is very good because then you're not depending on which order the columns are present in the database. And if I press enter, I can add this stuff down here. So values and so on. And now I can pass the values in, right? So it's person dot get ID first. The second parameter, person dot get name. The third parameter, person dot get location. The fourth parameter, person dot get birth date. Let's format it a little bit better so that I can see the queries here. So insert, that's the query that we are firing in, and these are the different elements that we are passing in. Cool, right? So we are creating a simple insert query. We are setting the values to each of the question marks. So in the order, ID, name, location, and birth date. One of the things is in our database, we defined birth date as a timestamp. So we need to create a timestamp here as well. So new timestamp. And to the constructor of the timestamp, I'm passing in the get birth date. Let's import timestamp in first. So I would want to use the import timestamp from java.sql. And over here, the timestamp accepts a long. So I'll say get time and save it out. So what we did now is instead of person.get birth date, we are creating a timestamp and passing it in. That's all we need to do to be able to insert a row into our database. And the last one we wanted to do is to be able to update. So we would want to update the details of a person. So we would want to say update. The query would look a little different, right? So update person. The values would be set. We don't want to update the ID. ID is the primary key. So the only things which would be updated would be name. Name is equal to question mark. The next thing which we want to update is the location is equal to question mark. And we would want to be able to update the birth underscore date is equal to question mark. And we would want to be able to say where. So I would press enter here. So set is done. And next, what we can do is to write the where part of the query. So I'm saying update person, set the values where ID is equal to question mark. Make sure that you have spaces at the end. So space here, and the space here is not really important. So make sure that you have spaces so that the query is correct. So I would actually sometimes even put queries at start. This is an extra space which is not really needed, but this ensures that we are safe. So update person set name is equal to question mark, location is equal to question mark, birth date is equal to question mark, where ID is equal to question mark. The first question mark maps to name. So we need to change the order of the parameters. ID is no longer the first one. Get name is the first one, get location is the second one, next is the timestamp, and the last one is the ID, person dot get ID. Cool, isn't it? So now we have the methods to insert and update a person. Let's make use of these methods right now. So let's go here and run them in. So I would try and insert a new person. So I would say logger.info as the same thing. Inserting, I would give him an ID of 10,004. So when I look at the data.sql, what are the values I have? 10,003 is the last one. So I'll say 10,004. So I'll say DAO dot, what do we want to do? Insert a person. So I'll say new person, and I can set the values in, right? So the ID is 10,004. The second parameter, if I remember it right, is the name. Let's say the name is Tara, and we would want to be able to give a location, and let's say it's Berlin. And now I would also need to be able to pass a time. So I'll just say new date for now. Java.util, organize imports. That's it. I'll just organize the code a little bit by moving this a little down. We are now inserting a new row at 10,004, and also let's update one of these as well. So let's copy this, and I would say updating. Let's update 10,003. The values which we have inserted in, what the we have data.sql. I would say the name, so 10,003, these are the values which are present, right? By default, these are the values which are present. So let's take them. What I want to do is update 10,003 is what I would want to update. Be careful with the IDs because that would be exactly what you would be updating. I don't want to change the name. I'll leave it as Peter. And let's say the Peter shifted from Amsterdam, let's say, to Utrecht. And I'll leave his birth date as Sisted. So we are basically doing an update of 10,003. We are shifting him to Utrecht and we are inserting a new row for Tara in Berlin. Let's start the application now. You can see that deleting, number of rows deleted is 1, inserting 1004, it returned 1 row updated, and even updating 10,003 returned 1 row updated. That's cool because we were expecting only 1 row to be updated for each of these queries. So that's cool. Now let's go to the database and check the data which is present in there. Let's reconnect to the H2 console. Continue, please. Connect, and let's go to person and run. So if you see the person here, what data does it have? It has 3 rows. We have the last row which is inserted in. We deleted 10,002, so that's not here. 10,004, Tara Berlin is properly inserted in. And the other thing you can see is Peter is now shifted to Utrecht. He's no longer in Amsterdam. The update also worked. What we have done in the last few steps is we have defined methods in our person JDBC DAO to be able to retrieve values, update values, delete values. Whenever we are using JDBC, it's very simple, right? You just write the query which you would want to write. So the complexity is in writing the query. Once you have the query ready, then all that you need to do is pass in the appropriate parameters, and that's all. And that's all there is. Once you write the query, then you can set the parameters in and then execute them. I'll recommend for you to try with a different query. So try and write different queries, try and execute those things through the DAO, and try and call them from the demo application class and see how you would be able to do different things with it. Until the next step, bye-bye. Welcome back. Until now, we were using a row mapper called bean property row mapper. So in all the steps, we made use of this row mapper to map the results of the query to the bean, to the person bean. However, the thing is you can even define your own custom row mapper. So if the data which is coming back from the table is of a different structure compared to your bean, for example, if the column names don't really match, so if the column name does not match with the field name in person, so in those kind of situations you'd want to create your own row mapper. Let's define a simple row mapper for this person class. The way you can define a row mapper is by implementing a simple interface which is called row mapper. So I'll say row mapper of which bean you'd want to map the values to. Now I can define a person row mapper implements row mapper. I'm creating an inner class here because I would want this to be used only inside the person JDBC DAO. I would import the row mapper interface or Spring Framework JDBC. That's the one which we are looking for. You need to implement a specific method. So I do a control1 or command1 in here, add unimplemented methods. This is the specific thing that we would need to implement. So what I can do here is person is equal to new person. Oops, typo in here. What we would need to do is to return a person back. So now this code compiles. What the row mapper interface defines is how should you map one specific row. One row in the result set, how do you want to map it to the person? The number of the row is available, but most of the times you don't really make use of the row number. All that we do is get the value from the result set dot get int, and then we can say the name of the column. So I can say get int id. Where do I want to take that value and put it in? Person dot set id. Similar to this, we can map all the other columns manually. You can say set name. However, to be able to set the name, you need to get a string call name. Right? Name is a string. And the other one is location. So let's do that. Location. And this is also a string called location. And the last one is get date, right? So target underscore date. In the database, we have defined it as a timestamp. So what we'll do is get timestamp. And over here, we would want to set it to which field? To birth date. Make sure that you're using a small s, it's not a capital S. So timestamp is one word. So I'm using a timestamp to get the target date and set the birth date based on it. That's it. You have your person row mapper ready. And over here, now, instead of using this bean property row mapper, what I can start doing is use person row mapper. So I can say person row mapper. For the person object, it does not make a huge difference because the exact names match. So ID is ID, name is name, location is location. Actually, this should have been birth date. Where did I get the target date from? Okay, birth date. So birth date is maps to birth date. The framework is able to understand the fact that in Java we use birth date, and in table typically we use birth underscore date. So in this kind of a scenario, person kind of scenario, you don't really need a row mapper, but a lot of times your table definitions will be different from how your beans are defined. So in those kind of situations, you need to define row mappers. The advantage row mapper provides is now I can use this row mapper everywhere. So wherever I would need to map this table or this kind of rows, I can use the row mapper in all those kind of situations. So this specific logic which we are writing in here, we get a little bit of reusability around that by creating a row mapper. If you go ahead and run, you would see that there is no change in functionality as such. So you'd see that the find all would still be able to get all the rows from the database and it would print it to the log. You'd see that nothing has changed in that stuff. In this step, we looked at the last important concept in JDBC, that of a row mapper. Until the next step, bye-bye. Welcome back. In the previous steps, we talked about Spring JDBC. We saw how Spring JDBC is more advantageous than JDBC, and we understood how to do the basic operations using Spring JDBC. What we did was we implemented a person JDBC DAO where we implemented the find by ID, delete by ID, insert and update methods. Let's switch our attention to JPA. JPA stands for Java Persistence API. The way JDBC works, whether it's Spring JDBC or the normal JDBC, is you write a query first. That's what you do in anything that you do with JDBC, right? You write a query and map the values to it. So this is called mapping the values. So to execute the queries, you need a set of parameters. So you'd pass them using mapping. And also, what we would do on the reverse side is we would actually do something called row mapping. So once I get the results from the database, I would need to map them back to the beans. So I'm mapping it back to the person bean in here. The complexity with JDBC or Spring JDBC is the fact that writing these queries is not a simple task. In the examples which we have, these are really simple queries. But when we talk about really big applications, they would have hundreds and hundreds of tables. A couple of applications I have worked with have about 300 tables and the other one had about 500 tables. I mean, these are huge databases, and what would happen in those circumstances is your queries start becoming complex, and the amount of skills that you would need to maintain those queries become multifold. From a Java expert, expecting that kind of a knowledge is very difficult. So then what would happen is these queries are written by database experts, and that would make it very difficult to maintain the application. That's where JPA comes in. JPA says, why do you map a query and try and map the values and get the data back? Why don't you map the entities. So why don't you map directly an object to a row in the table? What we will do with JPA is we would define something called an entity. We will define the relationships between entities as well. So we'll define an entity called person and we would map it to a row in the table called person. We will map the fields from here to the columns in the table. You can say this person maps to a table person. This birth rate here maps to a field called birth underscore date. And you can also define relationships. If a person can have an address, and if let's say a person can have multiple addresses, then you can define the relationship between the person and the address as well. Once you define the entities and the relationships, the JPA implementation would take care of identifying the entities and creating the right queries for you based on the operations you would want to perform. So the job of writing the queries shifts from you, from the developer, to a framework which is called a JPA implementation. JPA is like an interface. It defines a set of annotations and a set of interfaces. Hibernate is the most popular implementation of JPA. So you can treat the JPA as an interface and Hibernate as the class. So Hibernate implements JPA. To make a long story short, Hibernate was actually present even before JPA. Hibernate was the most popular ORM framework in the last decade, and JPA came in after seeing the success of Hibernate. After seeing the success of Hibernate, Java EE said, okay, why don't we have a standard of how to do ORM? And that's where JPA came in. JPA is a standard of doing object relational mapping, ORM. What does that mean? Object is an instance of this class, right? So I'm mapping an object to a relation. Relation is a table. So I'm mapping an object to a relation. I'm mapping this object to a table, a relation. So this is what is called object relational mapping. JPA kinds of standardizes the ORM and Hibernate implements JPA. Actually, Hibernate has a lot more features than JPA itself, but what we'll do here is restrict ourselves to JPA, because once you use JPA, then that means you have the option of switching away to a different JPA implementation at a later point in time. You'll not just be restricted to Hibernate, but if some popular ORM framework comes in the future, then you can easily shift to that. In this short step, what we were doing was to get a high level big picture of JPA. In the next step, we would start with creating a parallel JPA thing for the person JDBC DAO. Until the next step, bye-bye. Welcome back. In this step, we would start with defining our first JPA entity. We would want to make this person class an entity, something which maps this bean or this class to a table. In a pom.xml, we already add in starter data JPA. So because of that, you get a JPA API. This JPA API, if you look at it, defines a lot of different annotations. One of the annotation which is present in here is entity. This is one of the annotations which we'll be making use of in this specific step. The other annotations which are also defined in here are things like column. You have an annotation called table and a lot of such annotations. So this is the API, and who implements this API? Who implements the JPA API? The Hibernate core. Hibernate is the implementation of that API. So all the code that you would have in here, there would be a lot of code. It will give functionality to whatever is defined in the APIs. So let's get started with defining our entity. How do I define an entity? The easiest way is to just say at entity. At entity, control spacebar. JavaX persistence. So this now maps. One of the things is JPA provides defaults. This person maps to a table called person. So even though there is an annotation called table, and you can put again person in here as the name of the table. So you can say name is equal to person to say this is a table that it maps to, but I don't really need to do because the table name matches with the name of the class. Other things which you can define in here are column mappings as well. So you can put a annotation saying column, the name of the column, you can put it in here. So I'll import it in control 1, import control column, and you can say name is equal to name. Over here, the names match, so I don't really need a column as well. The only thing that I would need to define on this specific thing is something called @id. It indicates that this is a primary key. One of the things I would want to do is I would want Hibernate to take control of generating the ID for me. I don't want to manually set the ID. Whenever I insert a new row, I would want Hibernate to be able to create the ID for me. How can I do that? I can do that by adding something called generated value. I would import generated value annotation in. This would make sure that based on the database, appropriate mechanism is used to populate the ID. Typically, what Hibernate does is it creates a sequence in the database and it uses this sequence to populate the value for this specific ID. So now we have defined an entity called person. On the ID column, we have made it a primary key by putting an ID, and we said, Hibernate, you generate the whole thing for us. The other important thing that you need to always remember is you need to have a constructor. So you need to have a no argument constructor. We have another constructor with ID, name, location, and birth date. But with Hibernate, I don't want to create the ID. So I'll create another constructor where I don't pass the ID at all. So what we are doing is creating a constructor with just 3 arguments. This would allow us to create a person, and we'll allow Hibernate to assign a value to that. That's it. That's all you would need to define an entity with Hibernate. In the next step, let's see how to create a repository to maintain this entity. Until then, bye-bye. Welcome back. In the previous step, we have defined an entity called person, and in this step, we'll create a new class to manage the entity. It is called a repository. So let's get started. So I would need to now say person JPA repository. I'll put it in a package called .jpa. Let's finish. One of the things I would need to say is this is a repository. That's number 1. One of the other things that you need to also say is we would do transaction management in here. So whenever we insert rows and delete rows, whenever we do an update to the database, transactions become very important. When you do 3 or 4 steps or 3 or 4 updates in a single transaction, you'd want all of them to be successful or all of them to fail together. For now, we would implement transactions at the level of a repository. Ideally, transactions have to be implemented around your business services. But for this example, we'll restrict our view to the repository. So we'll need to say this is a repository. We would need to have transactions around this. The other thing is we need to have some way to connect to the database. How do we connect to the database? That's the other thing that we would need to finalize. If you remember in Spring JDBC, we used a JDBC template. The JDBC template was auto-wired with a data source connection, and we use that to fire our queries. So what do we use in here in the JPA repository? That's another thing which we need to work on. And after that, the typical thing that we would want to do is to create our method to do the retrieve of the data. What we'll do is we'll start with find by ID method. So I'll copy the one from our person JDBC DAO. So here, now I would want to return the person for that specific ID. However, here I don't want to use JDBC. I'd want to get it by using JPA. Okay, let's get started now. The way you can say this is a repository is by @repository. And the way you can define transactions here, Spring makes it very easy to implement your transactions just by saying @transactional. 2 things done. Now I would want to be able to connect to the database. For that, there is something called an entity manager. Entity manager manages the entities. All the operations that you are performing in a specific session are all stored inside your entity manager. All the operations are not really stored in the entity manager, but in something called persistence context. Entity manager is the interface to the persistence context. All operations have to be going through the entity manager. Let's import the entity manager and the persistence context. Now, I want to do a find by ID. How do I do that? Entity manager dot find. There are a number of find methods inside the entity manager. The one which we'll be using is what entity? This is a person entity. And what is the primary key? The primary key is ID. That's it. You are now ready to get rocking and rolling. I've organized the imports in here. One of the things I will do right now is I'll rename the database demo application. I'll rename this. So I'll rename this to, this is Spring JDBC demo, right? Yes, rename the test as well. That's fine. And now I'll copy this and call this JPA demo application. This would help us have clear separation between them. One of the things is Spring Boot would do automatic component scan on this package as well. So Spring JDBC demo application would also get triggered. I don't want that to happen. So I'll remove the annotation, or even better, let's just comment out Spring Boot application annotation on the Spring JDBC demo application. What we are doing here is just to make sure that the JDBC code does not get fired. So we are doing a lot of updates in here. We don't want them to confuse whatever we are doing with JPA. So I've commented all that stuff out. Now I'll go to the JPA demo application, and now we want to do the same operations. However, what we want to use is a repository. Which repository? Person JPA repository, right? I'll import it in. I'll also rename this. It's not a DAO anymore. It's a repository. Some of the methods are not really there in the repository. That's okay. So there'll be compilation errors. That's fine. What we'll do is I'll move this line down. So we have implemented person find by ID. So let's comment all the other stuff out. We'll uncomment them as we implement the other methods. Cool. Now this is good. So we have now a simple find by ID 10001 method which is running using JPA. There's a small error that we would face when we run this, but I would rather show the error and then fix it. So let's do run as Java application. Okay, the error says table person already exists. What's happening here? Why is table person already existing? Where are we creating the table person? We are creating it in data SQL, right? So in data.sql, we are creating the table in here. One of the magics of Spring Boot auto configuration is the fact that it knows that we are using in-memory database, and it knows that JPA is in the class path. It knows that I am defining entities as well because I put the at entity. So what it does is it triggers something called a schema update, which is one of the Hibernate features. So what it does is when we are using a in-memory database, it automatically creates the schema for us. So from now on, you don't really need to define the table. So I don't need to create the table now on, because the table would be created for me by, who would create the table for me? The table would be created for me by the schema update. The schema update is triggered by Spring Boot auto configuration, and it's one of the features in Hibernate. So whenever we are connecting to a embedded database, the schema gets automatically created. All that you need to do is insert the data in. Let's kill the application and run it again. Now that's cool. Now the person object is being printed here. So person ID 10001, that's cool. But I'm not able to see the query which is being executed. I would rather want to be able to see the query so that I'm sure that the query which went to the database is right. How do I do that? I can do that by spring.jpa.showSQL is equal to true. That's it. All that is needed is this. And let's fire up the application again. Cool. Now, you'd be able to see the table definition in here as well. You can see that Hibernate is creating the table definition for us. This is triggered by Spring Boot auto configuration. The other thing you can also see in here is the query that is getting executed in here. You can see that there's a select from person with an ID being executed in here. In this step, we implemented a simple method to retrieve a person by ID, and also we enabled the show SQL for JPA. Other than that, we had to actually remove the definition of the person table from our data.sql because this is directly initialized by schema update of Hibernate, which is triggered by Spring Boot auto configuration. Until the next step, bye-bye. Welcome back. In the previous step, we implemented the find by ID method. Now, let's go ahead and implement methods to be able to update and delete a person. Public person, the method which we want to define to update a person is update person. And what we want to do in here is return entity manager dot merge. So whether you'd want to update or insert, you need to call the merge method. What the merge method does is it knows whether the ID is set inside the person or not. If there is an ID in the person which is already set, then it would try and update that person. If there is no ID set, then it would insert it in, as simple as that. So let's add another method. Let's call it insert. Actually, you don't really need two methods because the logic in here is really the same. There is no difference between an update and an insert as far as an entity manager is concerned. We have update and insert present in here, and let's go to our JPA demo app, and what we want to do is now bring the insert and update into picture. Let's organize our imports. Java.util.date person, that's it. So we are now inserting 10,004 and we are updating 10,003. So let's see if all that gets fired properly. Let's run the application again. I want to make sure that it's killed. Nope, it's not. So I killed it again and restarted it again. Let's see what happens now. You can see the query is getting written down here as well. So you see a select being written. After the select, what we are doing? We are doing a insert. So where is the insert getting fired? Here is the insert that is getting fired. So insert into person. You can see that Hibernate is calculating the value for us. So Hibernate is really taking the person ID and it's calculating the value for us in here. It's inserting a new person in, and after that, what is happening here is the update. So update person is happening for that specific ID. So here Hibernate is using a sequence before inserting it in. That's cool, right? So now I can go to the, let's go to the H2 console to see the data. Let's refresh so that we can get a new connection to it. Connect. Let's do a select star from person. You would see that Hibernate assigns an ID of 1 to the insert. So whatever we have inserted in, Hibernate assigns a value of 1 to it. The best way to do the insert is by not even passing a ID in. So we don't assign the ID, we would let Hibernate assign the ID because Hibernate would ignore whatever ID I'm passing in. This is the best way to do that. I'm not even passing in the ID and I would let Hibernate dictate the ID for me. And now when you run the application again, you would see that Thara would still have the ID of 1. That's the ID which is being assigned to it by Hibernate. Let's refresh this again, continue, connect. You can see that Tara is having ID 1. If you insert further rows into that table, you would see that you would get IDs 2, 3, 4, and 5, and so on. Hibernate would directly assign IDs based on a sequence it creates. So here, if you see, there's a sequence which is being created called Hibernate sequence. It will use the sequence to assign the IDs to different things. In this quick step, what we did is we defined a method to be able to insert and update a person. Until the next step, bye-bye. Welcome back. In this step, we will focus on deleting a person. What we want to do is delete the person out. So I'll say delete person. The way it works in Hibernate is before deleting the person, you need to be able to get the person out. So I would say find by ID, and get the person first. So I'll say delete find by ID. I don't want to pass in a person, so let's delete by using an ID. I'll call this delete by ID. I would take this and put it into a new local variable called person. And now I can call a method called entity manager dot remove. So this would remove the object. This would delete the person out, and this will actually not return a person. It's actually a void method. So I would say void. So delete by ID, entity manager dot remove person. That's how you delete a person. Now I can actually try doing that. So let's try and delete 1001. Unfortunately, I cannot use logger.info anymore because it's a void method right now. So it's deleting 10,002. So I'll leave it at 10,002. So repository.delete by ID 10,002, and you can start and stop the application, and we'll look at H2 console to see if 10,002 is deleted. You can see that the query is being fired, delete from person where ID is equal to something. If you go to the console and fire the query again, let's trigger it again, person, you'd see that 10,002 row is not present. So delete worked as expected. In this very short step, we actually implemented a simple delete with an entity manager. You can see how simple JPA makes it to talk to the database. All that we need to do is to define the entities and the mappings, and that's it. JPA would take care of the rest for us. Until the next step, bye-bye. Welcome back. The only method which is not implemented in the person JPA repository, which is present in the JDBC DAO, is the find all method. So I would want to find all the persons who are present in the database. How do I do that? With an entity manager, you have to write something called a HQL, Hibernate Query Language. So this is not really your SQL. In SQL, we would say select star from person. But with JPA, you need to write a query using something called JPQL, Java Persistence Query Language. So in this step, we'll use JPQL to define a simple query. Instead of directly defining the query, we will use a concept called named query, where we will give the query a name and use it. The way you can execute a named query is by saying JDBC template dot, actually not JDBC template anymore, it's entity manager dot, what we want to create is a named query. So we would want to give the query a name and use it in here. And I would give, this is find all persons. I'll give the query a name as find all persons. When we create a named query, we need to tell what kind of entity it would return. So this named query would return person.class. What I'll do is I'll not return it here. So let's remove the return. Let's assign this statement to a new local variable. So this is a named query. To get the results out of the named query, what we need to do is named query dot get result list, because we are expecting a list of persons as the return. So that's what we need to do, and I can now return this back. Thing is, we have not really created the named query yet. So where do we define the named query? The named query, we can define it on the entity for which the query maps to. So here I can define a named query. I can say named query Java persistence, and over here I can say name of the query is this, and the query to use is JPQL, Java Persistence Query Language query. The Java Persistence Query Language does not use database. It does not use tables from the database. It uses the entities. So what we would use here in the query is entities. So here I would want to query person. So I would want to get all persons. Query is very simple. Select P from, so I'm saying select all persons in here. So here instead of the table, this is actually referring to the entity person which is present in here. Now let's go to the JPA repository. Let's organize our imports and let's go to the JPA demo application and let's print find all. And I can remove this comment. This is no longer needed. Let's see if it prints all the users. There you go. Since we are calling find all at the end, it's printing the latest data which is present in the table. So ID 1 Tara, 10,001 Ranga, 10,003 Peter. Those are the rows from the database that are being printed. We are using a named query to get the values from the database. We use JPQL to write the query. In last few steps, with very little effort, we were able to migrate all our DAO stuff, which was written by using JDBC or Spring JDBC, to our person JPA repository. So whatever we are doing in the DAO, now we are doing in the repository, the JPA repository as well. Until next step, bye-bye.
Welcome to this section on JUnit in 5 steps. In this section, we introduce you to unit testing. If you are already familiar with JUnit, then you can safely skip this section. But if you are not, then we recommend you to complete this section and understand the important concepts of JUnit. This is a very short section, should not take more than 30 minutes. And the time you would spend here will definitely save you a lot of time when we are talking about JPA and writing unit tests for it. The home folder for this particular section is on our GitHub repository JPA with Hibernate. You need to go into 00 Framework Tool Introductions and you have 03 JUnit Introduction in 5 steps. Over here, you have a small description of all the 5 steps and the complete code example as it is at the end of this section. Also present are a couple of intermediate backups. I will see you in the first step.
In this step, we would want to understand what is unit testing and what is JUnit. Testing is typically done to make sure that the functionality of the application is as expected. This is to check whether the application is behaving as expected. In my experience, I've worked in a lot of projects and most of these projects have more than 1,000 source files, or sometimes it might be as big as 10,000 source files, 1 million lines of code in total. If you actually depend on deploying the application and testing it after deployment, then what would happen is you would be testing big chunks of functionality. If I build the entire application and deploy it and then test the entire application, then that becomes testing of the entire deployable. That is called screen testing. Unit testing is really different from that. Unit testing is testing a specific method or a class. Let's say there is a specific class. So inside this class, class 1, there are a lot of methods. So there is method 1, method 2, method 3, method 4, and so on. Unit testing is writing individual tests for each of these methods. In some scenarios, you also write unit tests for a group of methods, or you write unit tests for a specific class. But most of the times when you write unit tests, you are writing unit tests addressed at a specific method. JUnit is a framework which will help you to call the specific method and check whether the output is as expected. So let's say the method I'm talking about is doing a square and I need to pass a number to it. So let's say I would want to, it's accepting an integer n and it returns, let's say, another int back. In that case, the JUnit framework will allow you to call the square. So I'll say square of 3 and JUnit allows me to check is it equal to 9. If it's 9, then the test will succeed. If it's not 9, then the test will fail. JUnit will allow me to call the square method with another input, let's say 12, and check whether the output is 144. So JUnit is a framework which helps us do unit testing. So unit testing is nothing but testing a specific method or a group of methods. One of the most important advantages of using unit testing and using JUnit to write your unit tests is that these are automated tests. So I can keep running these tests automatically any number of times. So once I have the source code, I can keep running the unit tests every hour or whenever there is a change in the code. That would ensure whenever these tests fail, I get notified. So if, let's say, square of 3, the function is returning 8 instead of 9, then this test would start failing and I would be notified. So I'll get an email saying, okay, this test is failing. Check why it's failing. So unit test falls under the suite of automation testing. The important thing about automation testing is that these can be run under continuous integration. It's very easy to keep running these tests all the time whenever there's a change in code or at frequent intervals. The idea behind this step was to give you a quick introduction of unit testing and what JUnit does. If you did not understand a few things in this specific step, no problem. We'll help you understand JUnit much more in the next couple of steps. Until the next step, bye-bye. Welcome back. In this step, we'll create a simple Java project and add a unit test for it. So let's get started. The way you can create a new project, file new Java project, or you can go to file new other and select Java project from there. So I'll say file new Java project and I'll call this JUnit in 5 steps. You can go ahead and click finish. Once the project is created, I'll go ahead and create a simple Java class. So I'll create a class. I'll want to call this class as math, actually my math, and I would put it in the package com.in28minutes.junit and I'll say finish. So in this math, I would want to quickly create a method which would sum everything up. So I would want to create a sum method. It accepts a set of numbers. So I'll create an array of numbers. And what the sum method does is it would loop around everything. It would sum them up. So I'll create int sum plus is equal to I and return sum. That's it. It's a very simple method. It does not do a lot of logic as such. It's not initialized. Let's put it to 0. That's it. Now I've implemented this sum method, but now how can I be sure that the sum method is working fine? What I will do in these kind of scenarios is I would write a new unit test. One important thing is the source folder. So I'll create a new source folder. I would want to actually separate unit tests from the source code. It's not a good practice to actually put both unit tests and the code in the same folder. So what I'll do is before this, I would start with creating a new source folder. So I'll say right click new source folder and I would name it as test. And then I would start creating my test case. So then JUnit test case and I would call it my math test. The package name should be com.in28minutes.junit, the same as the class. So the same as my math, except that this is called my math test. And then I would click finish. It says JUnit is not on the build path. So do you want to add it? Yep, I would want to add it. Please do that. And now you can see that the source code is in the source folder. The test is in test folder. So this separation you should always maintain. Your source code should be in a different folder. Compare your test code. Your source code will be deployed to production. Your test code, you don't want it to be deployed to production. You'd want to keep it really separate. That's why we created a new source folder and created the test class in here. If you look at this specific test which is created, you'd see that there is an add test annotation around the test method. It's org JUnit test. The add test annotation is what is used to signify that something is a unit test. So when there is an add test annotation, it means this method contains a unit test. So now if you run this test, run as JUnit test, this would fail because here we are calling the fail method. So we are calling a fail method saying not implemented. This test is not really implemented yet. So if I remove that and I would actually run the test right now, you would see that the test succeeds. So one of the important lessons of JUnit is the fact that absence of failure is success. Even though I didn't write any test here, it succeeds because the way JUnit framework works is that unless any of the checks fail, then the test is a success. So even though there are no checks, absence of failure is success. So if there are no failures, then your test has succeeded. If the code has not thrown an exception or all the checks have passed, then your test would succeed. So in this step, what we did is we quickly created a new project. We created a new unit test, my math test. We saw that it was succeeding. We got a JUnit green bar, which is really famous. So this, whatever you see in here, is called green bar. It's a success bar. We have not really written a test yet, so we did not call the sum method and have not done anything with it yet. We would do that in the next step. In this step, we want to test the myMathSum method. So what we want to do is we want to call the myMathSum method. So the myMath has the method called sum. What we want to do initially is we would want to call it with a simple scenario. Let's say I would want to call it with an input 3, with 3 numbers 1, 2, 3, and check whether the sum is 6. So let's do that right now. So how do we do that? So I'll call this as sum with 3 numbers. I'm going to call the sum method with 3 numbers. So let's do that. So I would want to create an instance of myMath first. So myMath, just press Control Spacebar. Now I can import that. So you would now see that myMath, we are in the same package. It does not need to be imported. myMath is equal to new myMath. Now I would want to call this sum method. So myMath.sum. So I would want to call the myMath sum with 3 numbers. So I'll create an int array. So new int array. What are the numbers that should be there? 1, 2, 3. Right. So let's just do a sys out. Oops. Control space. Sys out this. Let's see what's being printed. The way you can run this is by saying right click, run as JUnit test. Anything with an add test annotation would be run as a JUnit test. So this is succeeding. The important thing for us is what's in the output. Absence of failure is success. So how do I check that result of this is 6? How do I check that? So now let's create a small variable. So I'll call this result. So result is equal to this. I would want to check now. I would want to check that the result is 6. How do I do that? So what we want to do is we want to check that result is 6. That's where the JUnit assert comes into picture. So if you type in assert equals is one of the important methods which is present in JUnit. So if you type in assert equals, the assert equals can check whether the expected and the actual values are the same. So the expected value is on the left hand side. So I'm expecting it to be 6. So I'm expecting the actual value is on the result. I'm expecting result to be 6. So let's see what would happen now. Okay, cool. This is 6. So if, let's say, there was a mistake, I was actually expecting a 5, what would happen? It's saying JUnit is saying assertion error, expected 5 but was 6. And if you double click the line, it would even take you to the exact one. So this is what JUnit framework is used for. You can write tests around it. So now I've tested with 3 numbers. So I'll also do a few other test cases. So I'll copy this and now say sum new int, let's say with just 1 number. So if I call it with 1 number, what should be the result? So instead of with 1 number, just 3. What should be the result? The result should be 3. Run as JUnit test. Success. Cool. Let's say there was some bug which is introduced in here and somebody, instead of returning sum, had written sum plus 20. So somebody was coding this method and they made a change here. Let's see what happens to the test if you run it right now. Aha, the test starts failing. This test says I'm expecting 3, but the result is 23. This is what would happen when JUnits are continuously run. Let's say one of your projects made a mistake in the implementation of your method. So you have implemented the method, you wrote the test, and later your friend or your project mate is changing your code and he introduced a bug. What happens when we run JUnits continuously is that the JUnit would find the bug and the test would start failing. And now you can actually go ahead and start fixing the test. So you go ahead and fix the test and run it, and the test succeeds. That's perfect. One small improvement that we can do in here is, instead of creating an instance of my math in every test, I can create one common instance. And now I can actually right click, run as JUnit test. It succeeds. And the other thing is I can also inline this variable. So why do I need to create a variable called result? I can directly call the method in here. Shortcut is Alt-Shift-I and inline, and Alt-Shift-I, inline. Oops, I should do it here. That's it. So this is very simple JUnit to check whether our sum method is working fine. So in this step, we wrote a simple unit test to check whether our sum is working fine. In the previous test, we wrote a unit test for the myMath sum method. What we want to do now is to understand more about the assert and the assert equals method. So I'll create a new class. So I'll create a new test case, JUnit test case. I'll call this assert test. So I'll call this assert test. I want to check my understanding about assert. So if you are learning something about Java and you want to check whether your understanding is correct, then JUnit might be a really good way to check your understanding. So here what we want to check is our understanding of assert. So assert true. So we want to check whether two things are equal. How do I do that? Assert equals. If I say the same number here, what would happen? Test would succeed. However, if I have a different number here, what does it do? What would happen to the test? Assert equals would fail. It says expecting 1 but 2. So assert equals basically checks whether the left hand side and the right hand side are the same. You can run assert equals with, there are multiple variations of assert equals if you look at assert equals. So double long object, double float string. So you can actually do assert equals with any kind of arguments. The other thing about assert equals is there are a couple of other assert methods called assert true. So assert true can be used to check whether a condition is true. So you can put a condition here and check whether the assert it's true condition or not. It's kind of a shortcut. So I could have actually done something like assert equals and said true comma true. So assert true is kind of a shortcut for that. Assert true and condition. You want to check whether a condition is true, I can use assert true. So actually here I'm hard coding the return. So you could actually call a function which is returning something and you want to make sure that it's true. You can use an assert true for that. The opposite for assert true is assert false. So assert false is more in scenarios where you want to check that the condition is false. So if the condition turns out to be true, then this would. One of the important things that we would already see is that we are doing a static import of all the assert methods. Similar to normal import, static import is used to import static methods. So instead of saying assert.assert equals, what it allows us to do is just directly use assert equals. Because I did a static import of assert equals, I can directly use assert equals in here without saying assert.assert equals. That makes the code much more readable. The other assert methods are assert not null. This is used to check whether a value is not null, and the other one is assert null. Obviously this is used to check if a value is null. So if you're checking an object and you want to make sure that it's null, then you can use assert null. If you want to make sure that it's not null, then you can say assert not null. There's a assert not equals also present, but it's not really as frequently used as assert equals. The last one is to compare arrays. So if you want to check whether two arrays are equals, then you can use assert array equal. You are getting an array as an output, so you are getting an array as a result, and you want to check all the values in that specific array, then you can use assert array equals. There you go. Those are the different kinds of assert methods that are present in JUnit. In this step, we took a quick look at the different assert methods which are present in JUnit. JUnit test. In addition to add test, there are a few more annotations which are present in JUnit. In this step, we'll look at them quickly. One of the important annotations is something called at before. At before is one of the annotations which is present in JUnit. So I'll say public void, and I'll do a sysout to be very easy. So sysout control space, I'll say before. I would want to actually add in something. So I'll say test1 and I'll call this test2. So now let's go ahead and run the test. The shortcut is Alt-Shift-X, run JUnit test is T. So Alt-Shift-X T also runs the unit test. So you can see that before is running test2, before test1. One of the important things with JUnit is there is no guarantee of how the tests are run. So this test can be run before this test, or this test can be run before test. All that JUnit guarantees is the test will be run. The order is not really guaranteed. But the thing which is guaranteed with add before is the fact that the before would be running before every test. So if you want to do something before every test, like you want to establish a new connection to the database or something of that kind, you can do that in the add before. So add before test1. So you can see that in this example, when I'm running only test1, before and test1 are running. If I run the entire test, so let's run the entire JUnit test again with 2 tests. So you'd see that before method is invoked before every test. So before method, next the test. Before method, next the test. Similar to before, there is something called after. So the name of the method does not really matter. What matters is the annotation. I'm doing a command 1 to import this, and this should be called after. Alt-Shift-X, run JUnit test. So you can see that before test, after, before test, after. So the after method is run after every test. So if there is some cleanup that you would want to do after every test, then you can do that in the after method. Similar to the before and the after methods, there are things called before class and after class. Before class and after class. There's a small thing that you need to do before these pieces of code would compile. One is import the before class, command 1, after class. However, if you run this right now, you'd see that there would be an error. So it says initialization error. Why is there an initialization error? It says method before class should be static. One of the things that you need to remember is the fact that before class and after class are class level methods. So they are applicable for the entire class. And all class level methods should be static. In JUnit, before class and after class should be static methods. Right click, run as JUnit test. That's it. So now I'll have to differentiate. So I'll call this before class and after class. Now let's see what happens. Now you can see before class, before test2, after, before test1, after, and then after class. So before class and after class are run before all tests. So before any test runs, before class would be run. After class would be run after all the tests have completed execution. Probably things like establishing a database connection might be things that we would do in a before class. Initializing some data for the test, probably something that can be done in a before class. Sorry, in a before method. In this step, we looked at few important annotations that are related to unit tests. One is before and after. Before and after are run before and after every test method. And before class and after class, these are run once for every test class. The idea is not to really make you an expert on JUnit. As we do more examples with JUnit, you'd gain more expertise. But the idea was to introduce you to the JUnit framework and think about how you can make the best use of them. For me, the two important reasons why JUnit framework is famous and it's widely adapted is A, it's automation testing. So you can keep using it multiple times. I can keep running these tests almost every day whenever there's a code change, and I would be able to find bugs very fast. Also, another purpose why JUnit can be used is whenever you are learning something. So whenever you are trying a new concept, you can write a JUnit test for it and try to make sure that you are understanding that concept really well. At In 28 Minutes, we really believe that JUnit is a framework that all programmers should master. And we would recommend you to try these examples again and try to understand them really well. Until the next step, bye bye.
Welcome to this section, JPA with Hibernate in depth. This is the main section of this course. All these sections until now are setting you up to be able to make the best use of this section. In this section, you'd learn the basics of entities and the different annotations. You'd learn how to create relationships between entities and also how to define inheritance hierarchies. We will learn Entity Manager and persistence context in depth. We will also discuss about the various ways of querying data from the database using JPA, JPQL, native queries, and criteria API. We will understand transaction management and also how to do performance tuning for your JPA application. We will also discuss how to implement caching with first level and the second level caches. The home folder for this specific section is 02 JPA Advanced. Once you get into this section, you'd see the details of all the 85 steps and the complete code example at the end of the section. Also present are intermediate backups at different stages of this specific section. I welcome you to the most important section of this course, and I will see you in the first step.
In this step, let's create a project which would serve as the starting point for all our advanced JPA stuff. We would want to create a Maven project with Java. I'm using Spring Boot 2.0.m3. It's fine to use any version which is about that. Group ID, I'm entering it as com in 28 minutes JPA Hibernate. And the artifact name, I'm just giving it as demo. So it's group ID com in 28 minutes JPA Hibernate. The artifact name, I'm giving it as demo. That's basically the name of the application that we are creating. What I've already done is I've chosen in 3 dependencies: web, JPA, H2. So these are the 3 dependencies that you would need. Once you choose these dependencies, we are all set. Let's get rocking and rolling and click generate project. This would download a zip. We have done this multiple times earlier, so this should be very easy for you. You can import this zip into your Eclipse. How do you do that? I've extracted the zip and placed it on some folder on my hard disk. What I'll need to do is do a file, import existing Maven projects, choose next, and choose the directory where you extracted this zip file to. I have extracted it to in 28 minutes git JPA and Hibernate with Spring Boot 02 JPA Advanced. That's the folder where I extracted the zip to, and I'm importing it right now. I'm clicking the finish. This would import the project. So it would bring Maven into picture, and Maven would read the pom.xml, and it would import everything that is needed to execute this project. If this is the first time you're using that specific version of Spring Boot, this might really take a little while because this would download all the dependencies onto your local Maven repository and use them to create your project. Once the project is created, it would look something like this. You have source main Java. This is the folder where we would put all our code, all our production code. Source main resources is where we would put all our configuration. You'd see application.properties, which is already present in there. If let's say I would want to configure something about Spring, I would want to configure something about Hibernate, all that configuration can be done in application.properties. We also have source test Java. Source test Java is the place where all our test code would go. We would write a lot of unit tests during this course, and all the tests that we would be writing would be present in source test Java.
All the test code that we would write over here will not be really part of the deployables. What do I mean by the deployable? When our code goes to production, we would create a jar or a var. All the test code will not be part of that jar or var. The test code is to ensure that all the code is working fine. It is not really needed to run your application in production. Other than that, you would see Maven dependencies which are present in here. You have a wide variety of Maven dependencies which are coming in because we chose 3 dependencies in here, right? So we chose JPA, H2 and web. So if I open up the pom.xml, you'd see that there are those dependencies: JPA, starter data JPA, starter web, and H2. These are the 3 things which we chose, and these are the 3 things which are present in here. In addition, always Spring Boot adds in a test dependency. So the Spring Initializer by default adds in a dependency on the starter test. This is the one which we'll be using to write our unit tests. To make sure that you have your application running, what you can do is demo application test, do a right click on it and say run as JUnit test. So this would launch up a test. This test would launch up something called a Spring Boot context, and this would check whether everything launches up fine or not. If this is the first time you are launching it up, it will take a little while. So let's be a little patient with it, and over some time you'd see that the application would launch up. And if I want to see the console, I can say Windows Show View, and I can bring up the console. You can see the console in here with all the log that is being printed. There's a lot of log which is coming in here. The JUnit bar shows a green bar. This shows that JUnit has succeeded. The other thing you can also do is do a demo application, right click, run as Java application, and you would see that you would be able to run that successfully. What I'll recommend you to do is to play around. So try and see what's in here, try and spend some time looking at the folder structure, try and see what is in the pom.xml and other things like that. And I will see you in the next step. Welcome back. In this step, let's create a simple entity for something called a course. During the next steps, we would be playing around with these concepts called courses, students, reviews, and things like that. These are very simple things to understand, right? Instructors create courses, students do the courses and leave reviews. I mean, that's basically the concept. And let's start with creating an entity for a course. So I would start with creating a new class. So let's create a new class, and I would want to call this course, and all the entities, the course will be an entity. Entity is like bean plus plus. A typical Java bean can be used for any purpose, right? So I can use it to store data to the database, or I can take the data from the database, put it in it, and use it to transfer the data to other layers and a lot of other things. Entity is a specialization of the bean. We use an annotation at entity to define that a bean is an entity. So this is without the at entity annotation, this is like any other Java bean, but we use at entity annotation to make this an entity. Import entity javax persistence, and inside the course the different fields that I would want are, let's start with the ID field. In relational design, all tables should have primary key. Primary key basically is something which is used to uniquely identify a row in that table, and the way we define primary keys is by using an at ID. So at ID indicates that this is an ID field, this is a primary key. The other thing I would want to make sure is I would want JPA to generate this for us. So I'll say generated value. I would not want to assign an ID field. I would want JPA to generate that for me. So I'll say add generated value. The other field I would want to start off with is name. So private string name. We basically have a course with a private long ID and a private string name. Those are the two fields that we would want to use. Let's now create a simple constructor, public course. I don't want others to provide the ID. I only want them to provide the name. So string name. That's the constructor I would want to define. Who is using the course class will provide a name, and Hibernate would provide them with the ID. So this dot name is equal to name. For this bean alone, we would do this manually. Let's
have a getter and setter for the name created. So for the name, let's have a getter and setter created as well. So generate getters and setters for name. So now we have the getters and setters for the name. All shift S generate all shift S, or right click source generate. And I would want to now generate a getter and setter for ID. For ID, I only want to generate a getter because I don't want others to set the ID. So I'll choose only the getter. That's it. So we have getters and setters for name, getters for ID. We have a constructor. One of the things JPA mandates is a default constructor. What would happen is when I provide a constructor, the default no argument constructor that Java typically provides will no longer be available. To counter that, I would need to provide a default no argument constructor. This constructor will be used by JPA to create this specific bin. This is one of the things which is mandated by JPA. You need to have a no argument constructor. Protected would ensure that other classes which don't inherit from course will not be able to use the constructor. In this step, we define the course entity. In the next step, we would create a repository so that we can access the data from the course. We can create courses, delete courses, and things like that. I'll see you in the next step. Welcome back. In the previous step, we defined a course entity. In this step, what we'll do is we'll create a repository so that I can manage the courses. I can create courses, delete courses, and things like that. Let's quickly do that. So I'd want to create a new Java class. I'd want to call this course repository because this would be managing the course entity. I would call it course repository, and I would want to put it in a package .demo repository. So all the repositories that we would be creating, we'll be creating it in the package demo.repository. So let's go ahead and now finish this. In any repository class, what we would want to be able to do is to talk to the entity manager. So we would need to first have the entity manager auto-wired in. How do I do that? So at auto-wired entity manager, and I'll just call this manager, or you can just call this EM. So this is kind of the convention which we use. You can either call it entity manager or just EM. If you look at all the examples, traditionally they would be using EM. So let's use that as well in this course. So now I've done a Control Shift O or organized imports, and you'd see that the entity manager is imported in and AutoWired is also imported in. That's cool. So we now have the entity manager. There are three methods that we would want to create in the course repository. One is find by ID. We want to pass in an ID and get the course for that specific ID. So I would want to be able to pass in an ID 1 and get the course saying JPA in 100 steps. I would want to be able to save a course. So this save method I would want to be able to use to insert a course, as well as I would want to be able to update a course. So whether I would want to insert a new course or I would want to update an existing course, I would want to use the save method. The delete by ID method, I would want to be able to pass in an ID and delete a course. So these are the three methods that we would want to create in the next few steps. For now, what I would want to focus on is the find by ID method. So let's create this public course find by ID. I would want to return the course for that specific ID. What is the method in Entity Manager I can make use of? Entity Manager dot. If you look at the Entity Manager, there is a find method. We will look at all the other methods which are present in the Entity Manager a little later in a specific discussion on Entity Manager. For now, let's use the find method which is present in the Entity Manager. I would say Entity Manager dot find. What is the class of the entity? It's course dot class. So I would want to find a course whose primary key is this, and I would want to return that back. What we are doing is defining a simple find method. We have done this earlier as well when we were taking the introduction to JPA. Now what we'll do is we'll try and use this course repository when we launch the application up. So we have the find method defined. Now I would want to use this find by ID to get details of a course. How do I do that? I can go to the demo application. In the demo application, what I'll do is I'll make it implement something called a command line runner.
So I'll import the command line runner in, and I would need to implement a couple of methods. So control 1 or command 1 and add unimplemented methods. Over here, I would want to make use of the course repository. You're using Spring, right? So the way we would do that in Spring is we would auto wire it in. So in the demo application, what I will do is at auto wired, I'll organize the import so that everything gets automatically imported. And now I can make use of the repository dot find by ID. Can I find by ID? Do I have any data defined right now? Nope. We don't really have any data defined right now. So what I'll do is I'll create a course with an ID 10,001. Do you remember how we created the data, the initial steps of the JPA stuff? What we need to do is we need to create a new file. So what I'll do is I'll create a new file called data.sql. There's a new SQL file. I'll call this data.sql and say finish. And over here, I'll say insert into course. For now, course has only two fields, ID, comma, name. And I would say values 10,001, comma, let's say JPA in 50 steps. Important thing, use a single quote, not double quote. So this should be a single quote. The other one is that you should end it with a semicolon. I've made a typo in here. So it should be insert into course ID, comma, name, values. What this would do is this would insert a course into the table, and what the demo application does is when the demo application launches up, because it implements a command line runner, this run method would launch up, and this would get the course at the ID 10,001. Let's assign this to a new field. Oops, not new field. I would want to use a new local variable. I would want to call this course. Over here, I would want to use a logger. The way I can get a logger created is very simple, right? So private logger, we'll use SLF for JLogger. So private logger is equal to logger factory dot get logger for this specific class. Now I'll organize the imports. So import logger, I would want to use SLF for J, and that's it. So we have the logger present now. So I would use the logger to log this. So logger dot log, logger dot info. You can log the details of the course, comma course. So what would happen? Course details, course 10,001 is this. I can launch this application now to check whether everything's working fine. When I launch the application up, I get an error. It says application failed to start because field repository requires a bean of this type that could not be found. That's a bean not found error. What would you do when you get a bean not found error in Spring? You need to check which bean. So course repository bean is not found. Why is this not found? Think about it. This is Spring, and actually I missed the annotation repository on this. So let's import that in repository annotation, and now let's launch it again. If you're not really an expert at Spring, I would really recommend you to look at the appendix. There's an introduction to Spring which would really help you to understand Spring and all these concepts of auto wiring. Now let's continue with what we are doing with the specific entity. Now you would see that there is a course 10,001 that's printed here, and it's printing the course. Over here, instead of this, I would want to actually print the details of the course. How do we do that? Think about it. So I would want to print the details of the course. I will create a toString method. I'll say right click source generate toString. Right click generate source toString. I don't need the ID, I just need the name. So I'll just say name, and I'll remove everything. I'll just customize this so that this is very concise. So course with the name is printed out. So let's stop the application, run it again. Cool. Now it's saying course 10,001 is course JPA in 50 steps. So it's getting the data from the database and printing it out. Okay, that's cool. That's a lot of things that we have done. We have created an entity, we have created a repository, we have created a command line runner. There's a lot of things that are happening in the background. What we'll do is, for the next couple of steps, we'll take a pause and revise what we have done until now. We would look at what is happening in the background. We'll turn a few switches on so that you would get more log, and we have more visibility into what's happening in the background. Until then, bye-bye.
Welcome back. Now that we have a simple entity working, this is the best time to play around and also to understand what's happening in the background. In this step, what we'll do is we'll turn on a few things. One of the things is we are using H2 as the database. So that's an in-memory database, and we would want to see what data is present in there. So we would need to turn H2 console on so that we can look at what's the data in the background. The other thing is we want to find out what are the queries Hibernate is generating, what is happening in the background with Hibernate. So we'll turn on something called Hibernate statistics, and also we will print all the queries which are being fired in the log. Let's get started with turning the H2 console on. How do I turn this H2 console on? Spring.h2.console.enable is equal to true. That's as simple as that. So this would enable H2 console when we launch it up next. So this would be enabling H2 console. Next, what we want to do is we would want to turn statistics on. So how do I turn Hibernate statistics on? I would want to see what's happening in the background with Hibernate. I would want to see statistics on it. The thing is, it's spring.jpa. We want to configure a property for the JPA. So properties dot, here we get into the custom field. So I would want to configure a Hibernate property, and what we want to do is Hibernate dot generate statistics is equal to true. This should help us generate a lot of statistics around how many queries are fired, what's happening in the background, and all that kind of stuff. In addition, I would want to set the logging level for one of the specific packages. So org.hibernate.stat. This is a package which is in Hibernate which is responsible for statistics. I'll say turn the logging level for this to debug. The next thing I would want to do, show all queries. Show all queries. So I would want to see what queries are being fired. So I'll say spring.jpa.showSQL is equal to true. This is cool because this would show all the queries. However, what I would also want to do is I would want to see what parameters are being set to these queries. We want the course 10,001. So 10,001 is a parameter. If I want to be able to see what parameters are being sent, I can say this. So this would enable the debug logging for this package. This is the package which is used when setting parameters. So, and the last setting I would want to also make sure is I would want to be able to format the queries. By default, the queries which are printed are not formatted. What we want to do is format the queries as well. This is a Hibernate property. So the way we would do that is format underscore SQL is equal to true. Whenever you would want to customize something related to Hibernate, all that you need to do is to append spring.jpa.properties to it. So let's get started with running the application. Let's see what would happen now. Let's stop the application and kick it off again. You'd see a lot of things that are printed in the console. What we'll do now is we'll take it step by step and see what's happening. So one of the first things which is happening is a table called course is being created. Spring Boot has this feature called auto configuration. When Spring Boot sees that there is an embedded database being used, H2 is an embedded database. So Spring Boot sees, okay, this guy is using an embedded database. So I would want Hibernate to create this schema for me. So it would turn something called create schema on. So what would happen is Hibernate would look at the different entities which are present in there and create this schema for them, create all the tables that are needed. So that's how the table is being created. The table is being created because of Spring Boot auto configuration. Spring Boot auto configuration enables the schema create, and Hibernate would create that schema for us. So that's number one. The next thing you would see is the execution of data.sql. So what we have done earlier is created a file called data.sql with a few queries. When Spring Boot sees a data.sql, then that gets executed. That's what you see next in here. So you see that the queries which are present in the data.sql are being executed. So it's saying executed SQL script from URL data.sql. That's cool. So whatever codes we have in there would be created. Next, what we have is a runner, right? We created a command line runner in which we are running a query. So what we are doing is get the details of a course. So the query which is being fired is select the ID name from course, where ID is equal to this. What is the ID that is being sent? I'm unable to see the ID that is being sent. Let's look at it a little later. For now, you can also see that there are metrics being printed. It's saying I've spent this much time preparing the JDBC statements, executing the JDBC statements, and a lot of statistics that are being printed. For now, these are the two ones which are important for us. So a query is being fired and how much time it's taking for that. That's cool. And we see that the course 10,001, which is what we printed to the log, printed in here. That's cool, right? So what is happening is the schema is being created, the data is being populated. However, one thing that concerns me is the fact that the value which is passed here is not being printed. Let's look at why it's not happening. I'll go to the application.properties. So we said logging level org hibernate type is equal to debug. Actually, I made a mistake. It should have been trace. You have to set the org hibernate type to trace to be able to see the values that are being assigned to the parameters. So let's trigger that off now. Kill the application, start it again. Cool. Now you would see that course ID. And what is the type? So it's saying, okay, this is 10,001. That's cool. So binding parameter 1 as begin 10,001. Now I'm able to see even the parameter values. I'm able to see the session metrics which are being printed in here, how many queries are fired, how many cache hits and other stuff which we'll talk about a little later. But for now, what we have is good application. So we are able to fire a query, we are able to see what's happening in the background, and that's really good. One of the things which we'll focus on during this course is not just trying to understand how to do something with JPA, but also trying to understand what's happening in the background. So we'll look at the statistics, we'll look at the generated queries and all that stuff. And in this step, we set that up. So congratulations, and I'll see you in the next step. In the previous step, we revised our understanding of what's happening in the background. In this step, we would want to write a simple unit test. So we defined a simple method to be able to find a course in the course repository. It's just a very simple method, but we would want to be able to write a unit test to this and check whether it's working fine. So that's what we would be focusing on in this step. One of the things which we missed doing in the previous step was to look at the H2 console. In the application.properties, we turned statistics on, we looked at them. We turned queries on, we looked at them. We enabled H2 console on, but we didn't look at it yet. So let's get to the H2 console now. Go to the browser and type in localhost 8080/H2 console. So this is the URL localhost 8080/H2 console. Just going there, you can see the values which you need to populate on your screen right now. So your driver class is org H2 driver. Your JDBC URL, this is the one thing which you need to notice in detail. It should be JDBC:/H2:mem:/testdb. The username is SA and password is empty. And you can say connect. Once you do a connect, you'll be able to see the course table which is present in here. This is what is called H2 console. Once you select a table and run, you can see the data which is present in here. For now, it's a very simple table, right? We have an ID, a name, but this console we would be using extensively through this course. This is not just select queries. If you want to insert data or delete data and things like that, you can do that from here as well. So this is very similar to your database client. If you're using Oracle, for example, you might be using something like SQL Developer or Toad. This is exactly the same, except for the fact that this is online. So this is a web browser kind of a thing. This is available as long as your application is available. So as long as your application is running, you have all the tables and the database available for you. When the application goes down, the H2 console also goes down along with it. Now, let's shift our attention to whatever we wanted to do in this step, which is to create a unit test for our course repository method. What we'll do is we'll create a class called course repository test and call this find by ID and see if the course which is returned back has the name that we wanted. The most important thing that you need to understand is the fact that your test code should be separate from your source code. So this is your production code. So the source main Java is your production code. Source main Java resources is your production configuration. The source inside sources Java will not be part of your production deployable. This is more to unit test your code. How do I create a unit test? What I'll do is I'll start with copying demo applications test. So I'll copy demo applications test and paste it out, and I would rename this as course repository test. The first thing I would do is also change the package name. So package name, we should match the package name of the class that is being tested. We want to test course repositories. The course repositories in the package dot repository. So dot repository. That is the package where I would want to put this. Control 1, command 1, move. Now we are inside that package. So course repository test, that's cool. If you see this specific test, the most important thing are the two annotations at the top. I'd want to launch a Spring context in my unit test. In these kind of situations, we use something called @run with Spring runner.class. So @run with Spring runner.class is used to launch a Spring context. The Spring context that we would want to launch is a Spring Boot test. So we would want to launch the entire Spring Boot context which is present in here. We would want to launch the entire demo application context which we have in here. So that's @Spring Boot test. Over here, I can even explicitly specify the Spring Boot context file that I would want to launch. I can say classes is equal to demo application.class. What I would want to launch is this demo application.class. This is the one which contains Spring Boot application. This is the context that I would want to launch. And I'm specifying that by saying classes is equal to demo application.class. What this would do is it would launch up the entire context. So if I do a right click, run as JUnit test, it would launch the entire context. And because this is a unit test, immediately it will kill the context as well. What would happen is first it is launching the Spring Boot context. So it launches the Spring Boot context. We have seen what are the things that would happen at the launch of the context, right? So the first thing is Hibernate creates the tables for us because it's enabled by Spring Boot configuration. Then it would run the data SQL files that would create the data that we would need. It would fire the query also, like the application class also is a runner. So if we look at the application class, this also runs the query which is present in here. So it runs the query, and then what it would do is it would run whatever code that we write in the test. In the example, we don't have any code in the test. So you can see that course repository test is being run in here. We don't really have anything in the test right now. So nothing will happen because of the test. And then the tables would be dropped and the whole context would be killed. So what would happen when I launch the test is the context is launched and the context is killed. For example, let's say I would want to log something in here. I'll go to the demo application and copy the logger stuff so that I will be able to log things in here. I copied the logger out. What I would do is logger.info. I'll say test is running. Context loads, run the unit test, right click, run as JUnit test, or you can select it from here. You would see that the whole thing happens again. The tables are created, data is populated, the query is run, and as soon as the query is run, the context is launched, then what would happen is your test gets fired. You can see here testing is running. Testing is running, what do I mean? I actually wanted to type in test is running, but it does not really matter. You can see that the whatever is in there is being printed in here, and once the test runs, it would actually drop the entire schema. The sequence of events is very simple. The context gets launched, the test runs, and the context gets killed. What we want to do here is we would want to test the course repository. So what we want to test is course repository and repository. Let's create an instance for it in here. I'll say this is going to be auto-wired, and let's organize imports, Control-Shift-O, Command-Shift-O. And now in the test, I can call whatever I would want to call. So repository.find by ID. And I would want to pass in an ID of 10,001, and I would get the course back. Assign statement to new local variable. Course is equal to this. That's cool, right? Now I can write a assert on the course. So I can say assert equals, what's the name of the course? Course get name. What should be the name of the course? Where do I get it from? I can go to the data.sql. Whatever name you have put it in here should be the name which should come back. So I'll do that. Oops. Let's get here and put it in, and I'll do a control 1, command 1, and add a static import for that as well. So now you'd see that I'm asserting. One of the things with assert equals, the left side is the expected value and this is the actual value. Try and make sure that this is adhered to. When you adhere to this, the JUnit messages which come up would be much more helpful. This is no longer testing a context load. This is testing what? This is testing the find by ID method. So I'll just call this find by ID basic test case to say that this is the most basic test case for the find by ID method. And now I can do a right click, run as JUnit test. The table is created. What does the test do? The test also fires the query again. So the test fires the query again. You can see that the course repository test is in here. The course repository test fires the query because we are calling the repository method to find by ID. What is the ID that is being passed? 10,001. You can see that the session metrics are being printed and the entire thing comes out. I would recommend you to play around with this unit test. So you can change this to JPA in 50 steps. Let's say I would want to change. Let's say I'll say JPA in 100 steps. What would happen? Try and play around with it. This test would fail obviously because name that comes from your database is JPA in 50 steps. However, I'm saying I'm expecting JPA in 100 steps. So you'd see that the test would fail. You'd see that it says, okay, JUnit comparison failure. I'm expecting JPA in 100 steps, but it was JPA in 50 steps. JUnit is also very helpful. It's saying what's the difference inside the brackets is 10 and 5. It's saying this 10 here it's 10, here it's 5. That's the difference. So this is where JUnit is really helpful. It would be able to automatically find out any flaws in your code. So if this find by ID is getting a wrong ID back or a wrong course back, then we'll be able to easily find it out because these JUnits would be running in continuous integration. This would be running as part of your build server, and whenever there's a bug in your code, this would easily find it out. So let's fix this. Let's go back to JPA in 50 steps. If you run this, you'd see that the test would succeed. If this is the first time you're writing unit tests, there are a lot of things that you might be learning for the first time. What I would recommend you to do is to try and play around with this unit test again and again. Try and write a simple unit test, a couple of more unit tests around this scenario. Maybe populate some data in here. So you can populate a new course in here and try and play around with it and see what would happen. One of the things that we really believe at in 28 minutes is the best time to learn is when you have something working. So you have a unit test working, you have a repository, you have an entity. Now you can play around with it. Take a backup, try and play around, break it, and that's the best way to learn. Until next step, bye-bye. Welcome back. In this step, what we'll do is we'll write a simple method to delete the course. The method which we want to write is public void delete by ID long ID. So that's the one which we would want to write. How do we delete a course? Again, entity manager comes to your rescue. The easiest way to delete a course is by saying entity manager dot remove your entity. However, I would want to first be able to get the entity for this ID. What I can do is I can call the find by ID. So first I would get the entity mapped by that specific thing. So course is equal to find by ID em.remove course. That's basically your code, right? So that's how you delete a course. I've not written it back. We'll leave it at void. So it's em.remove course. All that I need to do is get the course and say entity manager dot remove course. What we'll do now is we'll try and delete this course at this startup. So demo application, what I'll do here is over here, as soon as I print the course, I'll also try and delete it. So I'll say repository dot delete by ID 10,001. So what we are doing is application startup, we are deleting 10,001. And also what I'll do is I'll add a little bit more data. So in the data.sql right now I just have one row. Let's add a few more rows so that I can see the other ones as well. 1002, 1003. So let's say Spring in 50 steps, Spring Boot in 100 steps. You can have microservice code or whichever one you would like. I love all my courses. Now I would want to actually launch up the web application. So I'm launching up this one. Right click, demo application, right click, run as Java application. One of the things you should be cautious from now on is because you'll be writing unit tests and also running the application in parallel, you should be careful about what you are running. So if you go in here, you can see actually that these are the tests. So if you want to run a test, then you can choose this. If I want to run the application itself, I would choose demo application. So I would want to run the application. So I'm running demo application now. We would start by looking at the log and then we would look at the console. Oops. You can see that I'm getting an exception. It's saying no entity manager with actual transaction available. You're trying to manipulate data. You're trying to remove a course, but you're trying to remove it in a method which does not have any transaction around it. What is this transaction? Why do we need a transaction? Don't worry about it. We'll talk about transactions a lot more. All that you need to know is the fact that Spring makes transaction management very, very easy. So the problem is that the delete by ID is trying to delete a course. It's trying to make a change in the course details. If you look at the find by ID, it is just getting the details of the course. So it does not have a problem. But the delete by ID method, what it's doing, it's actually trying to remove a course. It's trying to delete a course. It's trying to make a change in data. If you are trying to make a change in data, you should do it within something called a transaction. For example, there are a sequence of steps, right? So if I'm transferring some amount from my account to my friend's account, there might be two steps, right? First, deduct the balance from my account and transfer the balance into my friend's account. I'd want to make sure that both of these are successful. If the second step fails, then I would want the first step to be reversed. I don't want to be in a situation where 100 rupees is removed from my account, but it's not credited to my friend's account. I don't want to be short by 100 rupees or dollars or euros, whichever currency you would want to use. That's what transaction management enables us. We have a detailed section on transaction management a little later. Spring really makes it easy to manage transactions. All that you need to do is say at transactional. I'm importing org Spring Framework transactional in here. Later we would talk about the difference between JPA and the Spring transactions as well. For now, I'm adding a transactional on the course repository. This would ensure that any change that is done, any method that is present in the course repository, any public method, this would act as the start and the end of the transactions. This entire thing would be running in a single transaction. So if anything fails, everything that is changed as part of this method will be rolled back. Let's now run this application. Cool. The application has started up fine right now. So let's see what query was the last one fine. You can see that the delete query was fired. Delete from course where ID is equal to, what is the ID that was sent? 10,001. And it says that there were specific amount of time was spent executing that statement. That's cool, right? So first what it does, it tries to select the course and then we are trying to delete it. That's the code, right? So find by ID, this executes the select and then this executes the delete. Let's see the data. Let's refresh our browser H2 console, connect again. Let's go to the course, run. You can see that 10,001 is no longer there because that's deleted. In this step until now, what we have done is we wrote a simple delete method. We executed that from our application. Next, what we would want to do is we would want to write a unit test for that. In the next step, let's work on that. Until then, bye. Welcome back. In this step, let's write a unit test for the delete by ID method. One of the things which we did earlier is to call repository.delete by ID in the demo application class. Actually, it's not good to keep modifying data in here. So I'll delete this from here. So I'm deleting the delete method in here. So the data would be as it is, which is present in the data.sql. All the rows would be present when we execute the JUnit test. So now I would go and write the method for delete. So I'm copying the method for find by ID. What we would want to do is delete by ID basic. So delete by ID, I would want to delete by ID. So let's do that. Delete by ID. Once you delete the row, instead of 10,001, let's use 10,002. So if I'm deleting 10,002, what should be the consequence? How can I test it? What would this do? This would delete the row from the database. So this will delete the course with an ID 10,002 from the database. How can I check whether it's worked or not? How can I write a unit test for that? I can check it by trying to retrieve that value back and seeing that it is null. So what I'll do is I'll say repository.find by ID 10,002. I would check that is null. So I would want to check that this is null. How do I do that? Assert null. JUnit has this assert null method, which would be helpful in checking whether something is null. So if you have an error on assert null, just do control1 or command1 and do a static import of it. That's it. So what we are doing in here is very simple, right? We started with deleting the delete which was done in here. So the run method was deleting the row. So I removed the delete from there. I would want to actually write a unit test for it right now. So I went to the delete by ID basic method. We call the delete and check that that particular thing does not exist now. So let's run this. Right click, run as JUnit test. You can see that the unit test has succeeded. That's cool. And now when I go to the log, I can see that the delete query is fired. So the delete query is fired with the ID as 10,002, and then the select query is fired. The select query does not come back with any details as such. So it does not come back with any details. So what happens? It would come back as null and the unit test would succeed. One of the important things about this particular unit test is this unit test is changing the data which is present. When we write unit tests, we would want to leave the state of the application as it was before running that unit test. So because this is modifying the state of the system, state of the data that we are having, what I would need to do is I would need to put an annotation called dirties context. So I just need to say dirties context and import it in. What would happen is after this test is run, Spring would automatically reset the data. After the test is run, Spring would reset the data so that for the other tests, the data has not changed at all. Think about this scenario. Let's say I'm getting the value of 10,002 in here. Let's say the name here we are checking for is the name for 10,002. If this test deletes that data and this test is dependent on that data to be available, this test would fail even though there is no problem with the code. What is happening is this test is deleting that data, so this test is not able to find it. That's not a good situation to be in with your unit test. That's the reason why we need to put an add dirties context. What Spring would do is it would execute this test, it would make sure that everything is fine. Okay, delete is working fine, and it would reset the data to whatever it was before this test. And that would ensure that this system is in a consistent state for the other tests as well. In this step, what we did is we wrote a simple unit test to be able to delete 10,002, and we check that after deleting the 10,002 does not exist. Until the next step, bye-bye. Welcome back. In this step, what we'll do is we'll create the save method. The thing is, with the save method, we would want to be able to insert and update data as well. So we would want to be able to both insert and update data using this save method. So how do I find if it's an insert or update? If course dot get ID, if the ID is null, then it means I would want to insert the row. So here I would want to do insert, else I would want to do a update. So that's basically what we would want to do. So if the course ID is null, then I would want to do a insert, else I would want to do a update. So how do I do an insert with an entity manager? It's very simple, right? Entity manager dot persist. Persist is the method I would want to use. Persist course. If course ID is not null, then what I would need to do is I would want to do a entity manager dot merge. Merge course. Once it's done, I would want to be able to return the course back. It's a very simple method. There's nothing complex in it in here. So all that we do is if course.getID is null, then we would want to insert a row, insert a course. Else, we would want to merge the course in. We would want to save the details. That's basically what we would need to do. Now, what I'll do is I'll save a new course, I would want to use the command line runner which we created, demo application. Over here, let's do the save. So I would want to create a new course, so repository dot save. So I'll say repository dot save, and I'll create a new course, and I'll give it a name, let's say microservices in 100 steps. You can kill the application if it's already there. Let's see if it's there. Nope, it's not here. So let's run the demo application again. So at the start of the demo application, what we are doing is we are inserting a new course in, and we would want to check that it's working fine. That's cool. So you can see here that the insert query is fired. Insert into course, name, comma, ID, values, and what are the values which are sent in? It's sending in microservices in 100 steps, and the ID which is sent in is 1. Hibernate calls a sequence. So what we have is inside the course, we said this is a generated value. When we say generated value, what Hibernate does is it uses the default of creating a sequence. So Hibernate creates a sequence, uses the sequence to find the next value for the ID. So it first calls the sequence, it gets the value back. So it uses that ID to insert the course in. Now I can go to the H2 console and see the data as well. Let's do that right now. H2 console, connect. You can see that microservices in 100 steps is present in here with an ID of 1. So you can try and play around. You can insert more rows into this table and try and play around to see if the insert is working fine. So in this step, what we did was we tried and created a save method, and we were successfully able to insert a new course in. Welcome back. If this is the first time you're writing unit tests, the things that we are doing in here with course repository test might be seeming really complex to you. You might not be able to clearly understand what we are doing in here. It might be really making you feel uncomfortable. And that's fine. Actually, the most important thing is unit testing is a very, very important skill. As we move on, unit testing would become a key differentiator between a bad programmer and a good programmer. And that's why we make extensive use of unit testing in our courses. It's not a problem if you're feeling uncomfortable with unit testing right now. What I would assure you is that by the end of this course, you'd be really familiar with unit testing, how to write unit tests, and what are the different complexities that are associated with writing unit tests. So just hang in, try and play around with the unit tests. If the unit tests seem a little complex for you at this point, don't worry. Whatever we are writing in the unit tests, you can also write in the demo application. So you can go here in the demo application, try doing the same thing in here and see the change reflect in the H2 console. So when you run the application, you would see that that specific change would be appearing in your H2 console. When you run the query select star from course in the H2 console, what would happen? The change that you are making would appear. So try and use that to try and get familiar, so you can try and play around changing the run method, trying to play around with the data, try to understand what's happening. And in the meanwhile, over the period of the course, you'd get familiar with unit testing and the whole thing. The thing which I really believe in is the fact that if you are uncomfortable at something, do it 100 times and then you'd really become comfortable with it. Okay, let's end the motivation stuff in here. Let's get back to what we were doing. What we would want to do is we would want to write a unit test for the save method right now. So in the previous step, we wrote a save method. So the save method is going to change the data. So it would dirty the context. So I'll use the same thing as earlier. So delete by ID. Nope. I would want to do a save. So what we would want to do is called repository.save the details of the course. The way we created the save method is that it is going to be able to handle both inserts and the updates, right? So if the ID is null, then it will try to insert, else it tries to update. So in the unit test, what we'll do is we'll try and test the update scenario. So what I'll do is I'll get a course and I'll update the details of it and check the value. So let's first get the course. So I'll use this course itself, find by ID 10001. I have a course details first I can check what is the name of the course, right? The name of the course at this point, it should be JPA in 50 steps. That's cool. So we got a course, that's done. Now I would want to update the details of the course. So how do I update the details of the course? Course dot set name, let's say JPA in 50 steps updated, and I would want to call the repository dot save with course. So before I'm able to check the value, I would want to be able to update that. So now that the update is done, now I would want to check the name of the course. I would want to do a course.getName again and check the value. So I'll say course dot, I'll get it again from the database. So course 1, I'll say course1.getName. It should be JPA in 50 steps updated. What we are doing in here is very simple, right? We are getting the course, checking the details of the course, we are updating the details, and we are doing a save, and we are checking whether that's running fine. So all that is very simple. Right click, run as JUnit test. The test is failing because actually I left last statement in here, so I'll remove that statement. So the test should actually look like this. So get a course, save the change the details, save the course, and check the value is fine. So right click, run as JUnit test. You'd see that the test is succeeding. That's cool. That's very good. Always good to see a green bar. Let's see what is happening in the test. What is happening in the test is, first, the select query is getting fired. So the select query is getting fired to retrieve the course details, and you can see that the ID which is going in is 10,001, right? So after that, we are changing the details. So we are saying JPA in 50 steps updated. That's cool, right? So now we are firing an update query to be able to update the details of the course. And then what happens is a select query gets fired again because we are trying to get the details of the course again from the database, and we are actually extracting the new value from the database. So that's pretty cool. We are able to see that that's succeeding. In this step, what we did is we wrote a test for the save method. We wrote a test for the update scenario. So we took the course from the database, we updated the value of the name of the course, and we checked whether that's being saved properly. Until the next step, bye-bye. Welcome back. In this step, let's quickly review all that we have done in the last few. Welcome back. In this step, let's quickly review all that we have done in the last few steps. We started creating a simple demo application using Spring Initializer, and then we created an entity called course, and then we created a course repository to be able to insert, update, delete, and do operations, do the typical CRUD operations on the course. The course repository helps us to do that. And we created a simple unit test called course repository test, and the course repository test unit tests the different methods which are present in the course repository. So if I look at the course, the important things that are present are, we are declaring a primary key called ID. A primary key will uniquely identify each row in a table. So if I say 10,001, there will be only one row in that table with 10,001. If I say 10,025, there will only be one row. At a maximum, there will be only one row with that primary key. And we defined a column called name. So this course table has two columns, ID and name, and we created a few methods, right? We created getters and setters, we created a constructor. This is something JPA needs. So those are the things that we established in our entity. Entity is a course. So typically, if without the entity, this course is like any Java bean. How do you make the bean special? How do you make the bean entity? By adding an entity. An entity is a bean plus plus. So a bean which is stored to the database, which gets the values from the database. That's your entity. This actually maps to row in your table. So an entity bean maps to row in the table. So there's a row in the table which is corresponding to this bean. That is what is an entity. And then we went to the course repository. We used entity manager find method to be able to find a specific ID. So I'm able to find a specific row of a course by using its primary key ID. And then we were able to write a method to delete by ID as well. So we used the ID to delete a row, and we wrote a method to be able to save the details. By save, we mean both insert and update. When the ID is null, we are trying to insert it in. Otherwise, we are trying to save the details. We are trying to update the row. And in the course repository test, we wrote the corresponding unit test. We retrieved the details of 10,001 and saw that the name of the course is as expected. We deleted 10,002 and saw that the value when we are retrieving find by ID 10,002 is null. So this row is deleted. One of the things is we don't want unit tests to change data. We don't, at the end of the unit test, we would want to actually reset the system back to the same data. And that we achieve by using @dirties context. So that ensures that any other test makes use of 10,002, the row is still there in the database. So this unit test would run, it would check all the things that it would want to check, and after that the data gets reset again. That's done by using the @dirties context annotation. And we wrote a simple save unit test as well. We took the course, we updated the name of the course, and we saw that when we retrieve the course again, we get the updated details back. Other than this, what we did until now is in the demo application, we used something called a command line runner. So what would happen is whenever the application gets launched, whenever this context gets launched, whatever is in the run method gets executed. So in here, as of now, we are actually creating a very simple new course. If you would want to play around, this is the place you can try and play around. So you can call any repository methods in here and go to the H2 console and see if they are reflecting or not. When you launch up the H2 console and look at the data for the course, you'll be able to see all the details that we have changed as part of our demo application. One more thing I would recommend you to do to get further understanding of what's happening behind the screen is to use the debug mode. So if I'm running the demo application, let's kill this. I'm putting a debug point in here. So double click down here and you'd be able to insert a debug point. And I can come here and now I can say right click, debug as Java application. All that we had to do was come to the demo application, add a debug point in here, and then, or actually it's called a breakpoint. So add a breakpoint in here by double clicking in there and right click, debug as Java application. Typically we use run as. In this situation we are using a debug as. Now it launches it up in debug perspective. So now I can say yes, and you'd see that we are inside the debug perspective inside the course method. If I go to the database now, go to the H2 console now and refresh the page, connect again and go to the course, run it, you'd see that the new course is not yet inserted. You can see that the new course is going to be inserted a little later in our piece of code. For now, what we are trying to do is retrieve the details for 10,001. The way you can execute this is by using your function keys, or you can use the keys which are present in here. So I would want to step over F6. So now the details of the course are retrieved. You can see what's happening in the log. I'll do a step over again. You'd see that the details of the course are printed. I'll clear the console again. And now I would execute this statement again. You'd see now that the row is getting inserted, insert statement gets called. You can see what are the values that are getting passed. You can see the statistics which are getting fired. And I can go here, run, and I can now see that it's having the new row present because that's inserted in, and also go ahead and go do a F8, function F8 that would complete the execution. Now I can actually now go and see all the data which is present in here. It would have all the data that is present at the launcher. So this is one of the other things you can do to be able to understand the whole thing further. This is called debugging. We are actually putting a debug point, launching the application in debug mode, and checking everything is working fine. In this step, we wanted to give you a quick overview of what we have done until now, as well as show you a few tips about debugging. Until the next step, bye-bye. Welcome back. One of the most important concepts behind JPA is this thing called an entity manager. In this and a series of next couple of steps, we would look at entity manager in detail. We'll try and understand all the background details about the entity manager. To be able to understand entity manager in depth, what we'll do is we'll create a simple playground method. I'll call this public void play with entity manager. I couldn't find a better name than that because there are a lot of things I would want to play with related to the entity manager. So let's use that name. I'm creating this in the course repository. And what I would want to do is I would want to be able to, this is the debug. So I would terminate the debug thing which is running in the background. In the course repository test, I'll actually start with a simple test. So let's create a very simple test. I'll just call this play with entity manager as well. And over here, what we would want to do is just trigger off the method which is present in the course repository. All that we want to do is play with entity manager. That's it. Repository dot. Let's remove all this stuff. We don't need all this. I would just want to trigger play with entity manager. Play with entity manager, the course repository test would call the course repository method, play with entity manager, and logger.debug, or let's say info. Oops. Okay, I don't have a logger in here. So let's pull out the logger from here just so that we are very clear what's happening where. I pulled out the logger and let's say logger.info. We are executing play with entity manager start. Okay, I guess we have all the setup that is needed. Let's run this. What would happen is the application context gets launched, so the schema is created, the data is inserted, and you can see that the play with entity manager start is triggered in here as well. So that's good. So we now have the entity manager play with entity manager method ready. So now let's start playing with entity manager. What I would want to start off by creating a simple course and saving it. So I would want to say entity manager dot persist. So entity manager dot persist is used to create a new thing. So if you want to create a new entity, that's the persist method. So I'll say new course of whatever you'd want to do. So let's say the new course that I would want to create is web services in 100 steps. So as we saw earlier, this would create a new row. So it would create a trigger an insert query and insert that row into the database. Now, instead of this, what I would want to do is take a step further. Alt Shift L. I'll take this into a local variable. I'll call this course. I'm setting a new name for this course. I'll say course.setName web service.100 steps updated. Will this update be saved? So what would happen now? Let's try and run this. So not this, actually I have to run the course repository test. Right click run as JUnit test. Let's see what's logged in the console. The test succeeds, that I would definitely know. But would the update be fired? So the course is inserted. What is the details that are inserted into the course? Web service in 100 steps. That's pretty cool. And you can see that here there is also an update course set name is equal to question mark where ID is equal to question mark. So it's also updating the new value that I have set it into the name into the database. So what's happening in the background is when I run this, when this method is called, first this row is getting inserted and then this row is getting saved to the database as well. But I have not really requested it to save this. How is this data getting saved? One of the important things is the add transactional annotation. So this entire method is in a single transaction. And while we are within the scope of a transaction, entity manager keeps track of all the things that were inserted through it, that were updated through it. Whatever things were modified through it, entity manager would start keeping track of them. In this example, the course is something which is being inserted through the entity manager. So whatever changes I make to the course are kept track of by the entity manager. I don't really need to say entity manager dot merge this to save the details. What entity manager does is it would keep track of all the things that are managed through it in here, and whenever there's a change on it, it would make sure that that change is persisted to the database. Now let's do one thing. Let's actually call the repository.play with entity manager in our launch of the application. So I'll do a window perspective, open perspective, Java. So I'll go back to the Java perspective. I'll open up the demo application class. And what I would want to do is I'll not really do all this stuff in here right now. So let's not need all this stuff. All that I would want to do is play with entity manager. So repository.play with entity manager, that's the only thing which is called from the demo application right now. Let's kill everything and start the demo application again. So what we are doing in the play with entity manager as of now is creating a new course and setting a name. And we saw that when we were running the unit test, there was a query which was fired to get the update done. But now I would want to actually show you the same thing in the database. Let's go back to the H2 console, continue, connect, run. It's web services in 100 steps updated. So whatever changes which we are doing in here are actually reflected down to the database. Okay, so that's lesson number 1 on entity manager. So if you are actually inside a that's lesson number 1 about entity manager. Whenever you are inside a transaction and you are managing something with the entity manager, whenever you are updating something or deleting something or you are inserting something in, that particular thing continues to be managed by the entity manager until the end of the transaction. So the course here, even though I only saved it here, whatever changes you are doing to the course later in the transaction are also being tracked by the entity manager, and they are also persisted. So if I do a set name something after that as well, then entity manager keeps track of those changes and persists them. We'll talk a lot more about entity manager in the next step. Until then, bye-bye. Welcome back. In the previous step, we saw that entity manager within a transaction keeps track of all the things that are managed by it. So whenever you call entity manager.persist, entity manager.merge, or any of the methods on a specific object, on a specific entity, whatever changes that are done to that entity in the rest of the transaction are also tracked by the entity manager and persisted to the database. Let's look at another example. So course is there. So I'll create a course 1 as well. So course 1, let's rename the course to course 1 and let's create a new one called course 2. So course 2, entity manager.persist course 2 and course 2.set name. That's cool, right? So now this course is persisted by entity manager, and this course 1 is also persisted by the entity manager. Let's give it a different name. So it's no longer web services. Let's call this AngularJS. And over here, we are actually setting AngularJS in 100 steps updated. You know what would happen when this gets started again, right? So the course 1 details get saved and the course 2 details also get saved. So we would see 2 new courses, web services in 100 steps, AngularJS in 100 steps. So that's what you would see. You can stop the video here, try and run the application and see what would happen. Entity manager also has a method called flush. So entity manager.flush. So what entity manager.flush does is the changes which are done until then, they would be sent out to the database. So I can call entity manager at .flush at multiple places so that the changes up to that point are sent out to the database. So now you can see this specific transaction as 4 steps, right? So the first step is creating the course, then we are updating the course 1. Actually, we are creating course 1 and updating course 1, and we are creating course 2 and updating course 2. Let's say I don't want the course 2 changes to be going to the database. So after this stage, I don't want all the course 2 data details to go to the database at all. How can I do that? There's another method in entity manager. So let's say entity manager dot detach course 2. So what would happen after this is the changes to course 2 are no longer tracked by the entity manager. So what you would see that course2.set name will not be executed. If I kill the application and start again and go to the H2 console, you'd see that the course2 name remains at AngularJS in 100 steps. Application has started up. You'd see that the updates which are done to the course 2, which was AngularJS in 100 steps, are not being saved because after the detach method is called on a specific entity, that entity is no longer tracked by the entity manager. Let's say I am creating the courses first. Let's say I move this stuff also down. So course1.set name, the updates to the courses, I'm actually moving them a little down. I'll also remove the flush in here so that we kind of treat this now as 2 steps, right? So the first step is creation of all the courses, flush it so they are saved to the database, and then I'm detaching only course 2 for now. So what would happen if you run it? Only course 2 is detached. So the course 1 name would be set to web services in 100 steps updated. However, the course 2 name will not be updated because course 2 is not tracked by the entity manager anymore. If I want to detach course 1, then I can do this as well. So entity manager dot detach course 1. You'd find that if you run this application and see the H2 console, you would see that the data would be as it is here. So it would be web services in 100 steps and AngularJS in 100 steps. These updates will not be saved to the database because those entities are not tracked by the entity manager at all. The other way of not tracking entities is by clearing everything out. So instead of calling detach on everything, you can also say entity manager dot clear. So this would clear everything that is there in the entity manager. So it would clear out everything that is being tracked out by entity manager, and everything including course 1, course 2 will not be tracked, and whatever changes you make to them will not be flushed out, will not be saved to the database. Let's kill the application, start it again. You would see that the data in the database would show these 2 values. The updates will not be saved to the database. Let's refresh. Connect, please. Run. So you can see the first 2 rows in here. Web service in 100 steps, AngularJS in 100 steps. The updates are not saved to the database. So in this step, we looked at how you can have entity manager not track a few entities. So by default, entity manager tracks everything. If you want to untrack a few entities, you can say entity manager.detach. If you want to clear everything out, you can call entity manager.clear. Until the next step, bye-bye. Welcome back. In the previous step, we looked at the clear method and also we looked at the detach method. In this step, we would take a quick look at the refresh method which is present in the entity manager. So in the previous example, what we did is we created courses, flushed, and we did clear. So what happens here is entity manager.clear. So it clears all the things that it manages. So it's not managing anything at this point. So whatever changes you make, they are not reflected in the database. Now let's set up for the next example for the refresh. Let's remove the entity manager.clear method call in here, and we have a flush here, so I don't really need a flush in here. So we basically have the inserts here and the updates which are going on here. So one of the things I would want to do now, after doing the updates, let's say these are done in different methods, these are not really done here. So after doing the update, let's say I would want to refresh course 1 with the details that are present in the database. So course 1, I would want it to have the details that are as it is in the database. I don't want the updated data for course 1 to go through. I would want to refresh course 1 with the contents from the database. How do I do that? The way I can do that using entity manager is by using entity manager dot refresh. So what would happen is all the changes which are done to course 1 are lost, and course 1 will be refreshed with the content that comes back from the database. So the steps are like this, right? So you create the courses. When I do a flush, these are inserted to the database. So these two courses are inserted to the database. I'm trying to make changes. These are still managed by the entity manager, so entity manager keeps track of them. And here I'm saying entity manager.refresh course 1. What happens? The course 1 contents alone, the contents of course 1 alone would be refreshed, and we would get the data from the database. Let's see what would happen. Let's put a debug point in here. I put a debug point in here. Let's kill the server and let's do a right click. Debug as. Oops. I put a debug point in here. I would need to debug the demo application. So I'll say I right click, debug as Java application. It's asking me if I would want to launch in debug perspective. I'll say yes. And I would want to go inside this method. So I'll say function F5, or you can say step into, which is present over here. Oops, this is going in a little deeper than what I thought. So since we already have a breakpoint at the start of the course repository, I would say continue, or step return is also fine. So now the execution is at course 1. So now let's see what would happen. I will clear out the console so that I can follow what's happening in here. Let's make this a little bigger and let's follow this closely enough. The shortcut for step over is F6. So I'll execute the new course. Nothing will happen with the database. Now I'm persisting it. It's just calling for a sequence. So as soon as I persist, entity manager is calling for a sequence and setting the value into the course. So if you look at the course, you can see that the ID of the course is set. What's the ID of the course? 1. That's the only thing which is set. The course is not still saved to the database. Assigns an ID for course 1, function F6. Now assigns an ID for course 2 as well. So course 2 gets the ID 2, I guess. So it should be 2, I guess. Yep, this gets a value 2. So now we are calling flush. What does flush do? Flush tries to save this data down to the database. So what would happen? So what did the flush do? The flush inserted the course in. So insert into course, it's saving the details down to the database, web services in 100 steps, and insert into course name, comma ID values. So AngularJS in 100 steps, that's inserted as well. So now 2 rows are inserted down into the database. Now let's execute the next statement. Before that, I would remove everything from the console. Function F6. So set name, nothing happens. And now, what is the data in course 1? Course 1 data is web service in 100 steps updated. That's the name. But now I'm trying to refresh course 1. What would happen? Observe carefully. Function F6. So you can see that a select query is fired on course 1. So you can see that the ID which is sent is 1, which is the ID of the course 1. And the data for course 1 is refreshed, and you'd see that it has a value web service in 100 steps. And now I'm doing a flush. But even though I'm doing a flush now, what would happen is the course 1 has the content which is present in the database. So this does not need to be saved at all, because this is exactly matching what's in the database. The thing which needs to be saved are the changes to course 2. So function F6, what is sent out? Update course, set name is equal to something, where ID is equal to something. Which ID? The ID which is sent in is 2, and the AngularJS course, the second course, is updated. The name for that is updated and saved down to the database. Now I can press function F8 to complete the execution. If you go to the H2 console now and see the data, you would see that this change is lost. So this change is not saved down to the database. So if you look at the course 1, it would have the name as web service in 100 steps. However, the course 2, the name as AngularJS in 100 steps. So in this step, what we did is we tried to understand the refresh method in detail. What we also did is looked at what's happening in the background for each of these steps. I would recommend you to do a debug step with this to understand the whole thing much more. I'll see you in the next step. Welcome back. In this step, we'll try and revise all that we have learned about the Entity Manager. Entity Manager is a simple interface. It's an interface to something called a persistent context. So persistence context is a very important concept as far as JPA is concerned. Here we are playing with a lot of entities, right? Course 1 is an entity, course 2 is an entity, and there might be other entities we are playing with in a single transaction. All the entities that are being saved through the entity manager are saved to something called a persistence context. The persistence context keeps track of all the different entities which are changed during this specific transaction, and also it keeps track of all the changes that needs to be stored back to the database. And we saw that entity manager offers a lot of different methods, right? So it offers a lot of fine methods to be able to execute queries against the database and retrieve data back. It offers persist method so that I can create an entity in the database. Entity manager merge method helps me to save the changes that I have done to the course down to the database. We can delete an entity by using the remove method. We also looked at the flush method, which helps to persist all the changes until now down to the database in the middle of a transaction as well. And also we looked at refresh method, which helps us to override the changes and refresh the content from the database. We also looked at detach method, which would detach the entity from the persistence context. What happens with the detach method is that particular entity, the changes to it are no longer tracked by the entity manager. Entity manager is a very important thing for you to understand. So I would recommend you to play around with the entity manager and also try and read the different stuff which is present inside the interface entity manager. Until the next step, bye bye. Welcome back. We're all used to writing SQL queries, right? So I can write select star from course. This is a SQL query. I can write select start from course where, let's say, name like percentage 100 steps. So I can do things like this. This would run the query and it would return me things which match that specific thing. So it's, if you look at the query, it's select star from course where name like percentage 100 steps within single quotes. So this is a normal SQL query which we write, right? So this is select star from course, and here we are defining a where condition where name like, we are defining a condition, or I can say where ID is equal to 1. This fetches only the first row because it matches the ID 1. So this is normal SQL. However, there is something called JPQL. This is Java Persistence Query Language. In SQL, what we do is we query from the database tables. In JPQL, we query from entities. So this is from tables, this is from relationship. SQL queries from where? SQL queries from tables, whereas JPQL queries from entities. Whatever JPQL queries that we write, those are converted into SQL queries by the JPA implementation, that is Hibernate. What we write would be JPQL queries, which would be using entities. So we write JPQL queries using the entities, and those are converted into SQL queries talking to the tables. So JPQL provides a way of writing queries using entities. How do we write JPQL queries? So for example, select star from course. Let's say I want to do a query of this kind. Select star from course. In JPQL, the syntax will be very simple. So select here, instead of star, I would need to do something else. So from where I would want to query from entity. Here we are not talking about this table course, but we are actually talking about the entity. The entity which we have in here is course. It's also having the same name as course. Select star from course as the name of the entity, and I'm giving it an alias C. I'll say select C from course. That's the JPQL query, which is similar to select star from course. What we'll do in this step, we'll write a few simple JPQL queries and try and execute them. So let's start with executing this query, select C from course C. What we'll do is we'll create a simple unit test. I'll copy the course repository test that we have and I'll call this JPQL test. And inside this, I would remove everything else except for the first test. So let's remove all the other stuff. And over here, I'd want to be able to execute a query. Instead of course repository, we would want to use an entity manager. Entity manager, or I can just say EM. And the way I can execute a query, em dot create query. That's the way you can actually create a query. Over here, I can pass in whatever we have written in here. Select C from course. So this is the way you can create a query, and you can execute the query by saying dot get result list. And I would take this and store it to a new local variable. This is returning a result list back, and let's log it out. So logger dot info. I'll put the query also just for us to be able to search. So, and it's returning what? It's returning this value back. What is that value? That value is result list. Cool, right? So let's now run this unit test and see what it returns back. Green bar, and you can see that this is what is printed on the log. So it's saying all the things that we expected. So it's saying web services in 100 steps, AngularJS in 100 steps updated, JPA in 50 steps, and all the other kind of stuff that's present in here. That's pretty cool, right? So now we are able to query using the JPQL. We would want to do a few more things with the JPQL. Let's write a couple of more simple queries. One of the things here is that I'm using a raw type. I'm not really using the fact that this query would return a course back. How do I do that? How can I get this query to say that I am going to return a course back? I can use another parameter, course dot class. So over here, what we are doing is typed. So now when I actually, let's create a local variable out of this. So this is a query, right? So when we create the query here, we are actually using something called a typed query. So typed query of course, we are saying this is returning a course back. However, if you look at this, if I extract this to a local variable by saying Alt Shift L and say query, this is using a simple query. Typed query is when I'm passing the type. I'm saying this is the query you need to execute, and this is the kind of results that I expect back. I expect results of type course.class. Now, when I get the results back, I can add type arguments as well. So I can change type to list of course. This is much better, right? So this is better typed. So I'm saying instead of just list, I'm saying this is list of course. Typed queries are always better because they make it easy to read your program. It makes it very clear what results you are expecting back. So this is find by ID typed. So here we are executing a typed query. The other thing is, just like the query we executed, you can also use where conditions in here. So we'll write a simple where condition in here. So find by ID. Oops, what's find by ID? Actually, let's just say query basic, or you can call this JPQL basic. And this is JPQL typed. And this is JPQL with a where. And over here, select start from course where our condition within single quote, where name like percent 100 steps. Now let's see what this would print. This is select start from course where name like 100 steps. These two courses are printed in the console. Web services in 100 steps and Spring Boot in 100 steps. Those two things which end with 100 steps are printed in. So JPQL, as we talked earlier, we are using entities. In a future step, we would actually use the relationships as well. Here we are just using entities. When we define relationship between course and students, what we'll do is we'll use that relationship also to write queries using JPQL. For now, all the queries that we have written are very simple ones. Until the next step, bye bye. Welcome back. In this and the subsequent steps, we would start looking at some of the important annotations which are provided by JPA and Hibernate as well. We should be careful about using Hibernate annotations because when we use JPA, one of the flexibilities you get is you can easily shift from Hibernate to any other persistence provider. So any other JPA implementation like TopLink or the others. But when you use a Hibernate specific feature, that means you are tied to Hibernate. So always remember that when you are using a Hibernate specific feature. Let's now start with one of the first annotations, which is at table. So at table, what is the use of at table? At table is used to define the name of the table. Here what we are doing is we are mapping a course table to course entity. However, there might be situations where this table is called something else. This table might be called course details or something of that kind. So in those kind of situations, you can use at table with the name. So for example, I can write now say the name of the table is course details. However, the entity I would want to store it in is course. Now let's import the JavaX persistence table entity table in, and I would stop and start the application again. You'd see that the table which would be used would be course details. So the at table annotation is used to define the name of the table. You can see that the application context fails to start because the data.sql contains, what does it contain? It contains course. It does not know about details. So let's look at the schema which is being created first. You can see that the name of the table which is being created is course underscore details. The course entity maps to course underscore details table. Actually here we are saying course details, so it automatically changes that and creates course underscore details, because typically when we are creating tables, the convention which is used is to separate words by underscores. So here instead of course I would need to say it course underscore details, course underscore details, course underscore details. Let's start the demo application up. Now let's refresh our connection to H2 console and course details. You can see that the table name is now course details ID name. So even though inside our entities we call it course, inside the table it is course details. Also the other thing you would observe is the fact that the queries and everything are now generated to course underscore details. So it's now select star from course underscore details. It's update course underscore details. So you see that like the JPA is actually doing a lot of magic. So even when the entity and the table names are different, whenever you are doing something with the course, the updates are directly sent out to the course underscore details table. The only thing that you need to do is to map it. You map it once and you can forget about it. So the fact that your entity name is different from the table name, you don't need to tell that in every query, in every repository and all that kind of stuff. All that you need to do is tell it once to JPA using the at table annotation, and that's it. You can forget about that. So what I'll do is I'll go back. I don't want to use course details. I would want to stick with course. So I would actually, I could do either this, or I can remove the annotation completely, and I would actually even revert the changes which are present in here and restart it. Now you would see that we are back to normal. We would be using the course table. So the table name is course. We are inserting data into course, and this would start up the course table. And let's refresh. It's called course, and you have everything as expected, as we had earlier before this step. If your name of the entity is different from the name of the table, then you can use the table annotation. Until the next step, bye bye. In this step, let's look at another important annotation at column. So at column, I can specify the name of the column. So here I can say this name column is not really name, it's called full name. I can do something of that kind. So what would happen? The table, the column in the table this field maps to would be full name. So whenever you update name, the changes would be sent to a column named full name. Let's try that. So let's change data.sql. Here it should be full name because in the table it's full name. Now if I stop and start the application and refresh H2, see the course, what does it have? It has full name. So the name of the column in the table is full name. However, the name of the field is different. So in that case, I can use name is equal to full name. And what are the other important attributes which are present in the add column? Let's look at them right now. One of the important things that is present in column attribute is something called nullable. So nullable is equal to false. That means name cannot have a null value. So let's say I'm going to the unit test now. So let's go to the unit test that we have related to the course repository test, and we have a play with entity manager method which is present in here, which is being called from here, right? So let's use that. Now if in here, let's say I'm setting a course.set name of this. So let's clear all this stuff out. So I would remove all the stuff which is present in here. I'll just leave the stuff which is related to course 1. So we are creating course 1. We are setting the name of course 1 to, let's say, null. What would happen? What do you think will happen? Will this work? I'll run the unit test which is present in here. So play with entity manager, run as JUnit test. It continues to succeed. That astonishes me. How does it happen? Let's go and look at it again. The reason nothing happened is we did not call the persist method on course 1. So I'll say persist course 1. Because we did not call the persist method, entity manager is not really managing the entity yet. So that's the reason why it did not fail. Now let's run that again. Now you'd see that it's failing. It's saying database integrity violation exception. Why is it failing? Because now what we said is this is a non-nullable field. This field cannot be null. Even if you look at the console and just go a little bit up and see the table definition, create table course, it creates a table with a not null definition. So this field cannot be null. And if you look at it, here it says JDBC SQL exception, null not allowed for this specific column. So it's very good practice for you to specify things like this. What this would prevent is bad data coming through. So in your application, you want the data quality to be really, really good. So all the possible constraints that you have in your data, it's good to set them using your add column annotation. So we looked at a couple of them. So we started with name and then we moved to nullable. The other things which are present in column are, one is unique. You can specify if this is a unique value. So across the table, this value will be unique. For example, fields like SSN. Those kind of fields are unique. So even though you don't want to use SSN as a primary key, you can specify a unique constraint on that specific field. You can say whether it's nullable, whether it's insertable. So whenever you say a column is insertable false, then whenever an insert is done, whenever a new row is created in that table, that column will not be sent. So in the initial insert query, that column will not be sent. You have updatable. Updatable is used to indicate if that column needs to be included in the update statements that are sent. So if you put updatable is equal to false, then in all the updates for that entity, that particular column will not be sent. The other attributes which you can specify on the column annotation are length. So if it's a string field, you can specify the maximum length. So you can say this field is maximum 255 characters and things like that. You can, if it's a number field, you can also specify scale and precision. In this step, we looked at some of the important things related to the add column annotation. We defined a different name for this specific column, and also we looked at what happens when I have an nullable set to false, and we also looked at various different attributes that are allowed on top of this annotation. What we'll do now is we'll quickly revert all the changes that we have done. So I don't want to use I would want to leave the nullable as false in here. That's cool, but I don't want the name as full name. So I'll go ahead and change this and change this as well. Change data.sql back. So now you would have a proper running application. Until I see you in the next step. Bye bye. Welcome back. In this step, we would look at some of the important annotations which are related to update time and create time. Some of the times, a few applications have the requirements that I would want to store when this specific row is updated last time and when this row was inserted. I would want to store the created time of that particular row, and also I would want to store the updated time of that particular row. In those kind of situations, Hibernate provides a solution. Remember, this is not a solution which is provided by JPA. So this is more of a custom thing which is provided by Hibernate. So let's say I would want to store private. I would want to be able to store the updated date, or it's called the last updated date. And I would also want to be able to store the created date. I'd want to store both the date and the time as well. So in these kind of situations, you would use something called local date time. This is one of the things which is introduced by Java 8. Earlier we were used to using java.util.date, but that's not really a good thing because it kind of represents date time, and all that kind of stuff. That's why in Java 8 it was made much more clearer, and there is something called local date time. So here we would want to store date and time. That's what we are specifying by using this local date time, and here local date time created date. Now these are the two columns that we want to make use of. However, we need to tell Hibernate that this is the last update date column. So every time you make a change to this row, this column needs to be updated with the timestamp. How do I tell that? The way you can say that is by using an annotation. Update timestamp. Update timestamp, if you look at it, as I said earlier, it's a Hibernate annotation. So it's a Hibernate annotation, not really a JPA annotation. So that's something you need to remember. And the other annotation which is present in here is at created timestamp. Now that we added in the update timestamp and the creation timestamp on the last update date and the create date, there are a couple of things that we would need to do before we are ready to test them. The first thing is data.sql, right? So in the data.sql, we are only populating the ID and the name. We are not populated the created date and the updated date. So I need to populate this. Data is directly inserted into database, and this does not go through Hibernate. So we have to manually put the data in here. Last updated date and created date. Let's put a enter so that it's much more clearer. And created date, last updated date, values, created date, last updated date, values. That's cool. Now let's put the values in as well. The values, I would use the sysdate function. So sysdate, for now it would populate both the things as the same. So whatever the sysdate was at that point of execution of the query. So that's cool. So the data at the insertion is now cool, right? Now what we want to do is, if you look at the play with entity manager method, this is called at startup of the application, right? So in our demo application, what are we doing? We are calling the play with entity manager. So over here, let's create a course. So we are already creating a course. So what I'll do is I'll also get an existing course and we'll update something on it. So what I'll do is I'll say course 2. Instead of creating a new course, I'll get it from the database. So we have a find by ID method in here. So let's use that. Find by ID, and let's say 1001, and course2 dot set. We want to set the name to update it. So 1001, what's the course name? It's JPA in 50 steps. Let's set the name to that. And now let's stop and start the application and see what would happen. What we have done until now is a couple of things, right? We defined an update timestamp, a creation timestamp, and then we updated the data.sql with the new data for sysdate, new columns. We put sysdate as the default, and then we went into demo application. We were calling the play with entity manager, and over here we are seeing that we are creating a new course, web service in 100 steps, and also taking one of the existing courses, JPA in 50 steps, and we are updating the description of it. Okay, that's cool. So let's go to the database and see what's happening there. This is the row which is created through JPA, right? So this is the one web service in 100 steps which we are inserting in. So this is having a created date and the last updated date. That's cool. So now this is having a created date and the last updated date. And this is the 10,001 thing which we updated. So which we wrote code in the entity manager to set the name to JPA in 50 steps updated. So for this one, you can see that the updated date is different from the created date. So for all the rest of the stuff, 10,002, 10,003, the updated and created dates are the same. So you can see that even including the milliseconds, they are same. However, for the 10,001, because when we updated the row, what happens? The updated timestamp gets updated. So this gets updated, and this is different from the created timestamp. You can also see the queries which are fired in. So when we look at the queries which are fired in, you'd see that when I'm sending the insert into course, what is it doing? It's sending created date, last updated date. So here are the created date and the last updated date for the web services in 100 steps course. And when the course is being updated, it's sending the created date, the last update date, and the name. You can see that the created date is being sent from whatever was there in the database. The old value was picked up from the database and sent as created date, but the new timestamp. So you can see that this is getting fired at 15, 21, 30, 182, right? So at the new one, 15, 21, 30, 180 is being sent as updated timestamp. The old value of the row is being sent for the created date. What we looked at is how to ensure that your created dates and the last updated dates are automatically populated for all the rows in your database. This is done by using a couple of Hibernate annotations at update timestamp and at creation timestamp. Until the next step, bye-bye. Welcome back. In this step, we look at named query annotations. So if you look at this specific thing, we are actually hard coding the query in. So this means if I have to reuse the query somewhere else, they would need to hard code it again. I would need to type in the entire query again. Named queries will help you to prevent that. So with named queries, you can assign name to a query and use it. So how do I create a named query? It's very simple. I can go to course. For example, this is the entity here, right? So here I can add a named query. So named query java x.persistence, and over here I can specify the name for a query, that's get all courses. I would like to prepend it with query get all courses, and comma, you can specify the query itself. So what's the query? The query which we want to use is this. Select C from course C. Now, this becomes a named query, and this can be used in other things. Now I can use here, instead of create query, I can say create named query. So create named query using what? Using this. So get all courses. Even here I can say create named query and use query get all courses. So let's see what would happen now. Run as JUnit test. I'm running all the 3 tests. Okay, cool. So this runs. So you'd see that the queries are properly run and you are getting the right details out. So this is select star from course. That's perfect. It's getting all the details and it's printing all the details out here. That's cool. So that's a named query. However, you'd see that here we have another query, right? I would want to create a named query for this as well. How can I do that? And let's say I come here and say at named query, name is equal to query get 100 step courses. Let's call it that way. And I would try and put the query is equal to the query which I copied. Aha. You can see that there is an error coming up. It's saying duplicate annotation of a non-repeatable type at named query. So this is not really a repeatable annotation. So because of that, what happens is I cannot do something of this kind. What I would need to do is when I want to define multiple named queries, I would need to use another annotation. It is called named queries. So JavaX persistence named queries, and over here I can say value is equal to, over here I have to define an array of named queries. So named query comma another named query, and this is how you do a set of named queries. So this is how you define multiple named queries. This is not really a very easy way of doing it. So now I have defined this, so I would want to use the named query here as well. So let's do that. Create named query, and that's cool. And let's run the unit test, JPQL test. Okay, there you go. So it's a green bar. If you look at the queries, you'd see that the queries are perfectly fired as well. So that's cool, isn't it? So in this step, what we looked at are the named query and the named queries annotation. Named query is used when you want to just define one query, but when you want to define multiple queries, then you need to use a combination of named query and named queries. Until the next step, bye-bye. Welcome back. In one of the previous steps, we looked at JPQL. We looked at how to write queries using JPQL, and we converted them to named queries in the last step. Let's shift our attention to something called native queries. Some of the times you have to use native queries to fire queries to the database. We'll look at those situations and also how you can fire native queries. So I'll copy the JPQL test and I'll call this native queries test. Native queries test. So native queries is nothing but sending a direct SQL out from your JPA. So instead of JPQL, where we talk about entities, when we are talking about JPQL, we are writing queries using entities. So the kind of queries that we would use in JPQL would be looking like select C from course C. However, this same query, when I execute as a native query, it would look something like select star from course. Right? So what we want to do now is we would want to be able to execute a query of this kind, select star from course. How do we do that? For that, we would need to use the native queries. What I'll do is I'll remove all the other stuff which is present in here. So all this is not really needed. So JPQL basic, actually now it's no longer native queries basic. That's basically what we are doing in here. So here, entity manager has a create native query method. So I can create a native query passing in the query that I would want to execute. So the query which I want to execute is select star from course. That's it. So here I would change this as well to select star from course and right click, run as JUnit test. So now you can see that the JUnit has succeeded, and also you can see that select star from course is being fired in here. So that's cool, and let's see what results are being printed in here. Over here you can see that all the courses are being printed properly. However, one of the things that you can see is here java.lang.object is being printed because it does not know which entity to map the result set to. You can tell the entity to map to by using the entity as the second parameter. So I can say course.class, and I'm saying that the results would be of the type course.class. So now if you execute the query, you'd see that the JUnit exits fine, as well as when I look at the log. So this is what is the output that is being printed. That's good. So this is a very basic native query, right? So there are advanced native queries that you can fire as well. So you can say create native query, and I can define parameters as well. So I can say where ID is equal to question mark, and I can say query dot set parameter, and I can say the position. So the position here starts with 1. So I can say position 1, the value I would want to set is 1001L. And I can get the result set and print it as well. So this is native queries with parameter. So I'm trying to get a specific course in here. What would be the output? So this is select where ID is equal to question mark. So I'm getting a specific course back. You can see that there is only one course that is being printed. That's JPA in 50 steps updated. That's the one which has the ID of 10,001. That's the course that's being printed in here. Now, I can also use named parameters. So instead of doing something of this kind with, I can say named parameters. What is a named parameter? So instead of saying question mark, instead of using position, I can use named parameter. So I'm saying colon ID, I'm giving it a name, and here I can say set parameter ID as 10,000L. So instead of using positional parameters 1, 2, 3, I'm using named parameters. So ID as 10,001. Now you would see there's not really any change in the result because it's the exact query which we are firing in, except with a different approach. So here ID is equal to colon ID. In this step, what we are doing is actually looking at a few things related to native queries. These are actually all the scenarios where we are looking at right now are actually those things where it's better to use the JPQL. But are there situations where you have to go for native queries? Yes, there are definitely situations where you have to go to native queries. Sometimes you have to set some tuning parameters, or you want to use some database specific feature. So if you're connecting to a database and it has a feature which is not supported by JPA, in those kind of situations you have no other option other than trying to fire a native queries. And the other situation where you would have to go for a native query is when you have to do a mass update. Let's say I would want to update all the rows in a specific table in a query. In those kind of situations, if you do it through JPA, then you need to get the row and then update. Get the row, then update. You cannot do a mass update using JPA. So in those kind of situations, we would use native queries. So the way we would do that, let's say I would want to update the updated timestamp on all this stuff. Native queries to update. So I would want to update all rows in the course table. So I would want to say update course set. I would want to set the updated date, last updated date of all the columns. Let's say I would want to set it to sysdate. When you're using an update, then the way we would do that is by using a query dot execute update, and this would return a integer back. This would return int number of rows updated, rows updated, and now I can log in number of rows updated. I can log the number of rows updated. Now, let's see what would happen. So doing this kind of stuff through JPA is not very efficient, because if you want to update this kind of stuff through JPA, you need to get the each row and then update row by row. There's no way to do a mass update through JPA. You can see that I'm getting a transaction required here because we are trying to change the data. You need a transaction, and for this test I'll make it transactional. So transactional. Ideally, until now in all our unit tests which were making changes to the database, we were calling a repository method, and the transactional is defined on the repository method, so there was no problem. This is the first time we are directly calling an update from the JNet itself. So we needed to add transactional to make sure that this is within the boundaries of a transaction. And you can see that I'm saying update course last updated date is equal to this date, and you can see that all the 4 rows which are present in the database are updated due to this. In this step, what we looked at is different kinds of native queries. We looked at how to set parameters to native queries. Also, we looked at how to execute an update using a native query. One of the things you need to make sure is whenever you're using a native query, you're not making use of persistence context. So if you have all these entities directly present in your persistence context, then you need to make sure that you would refresh them so that you get the latest stuff from the database. Until the next step, bye bye. Welcome back. In the previous steps, we focused on a single table course. We looked at different attributes that can be present in the course. We looked at different annotations that you can use with it, and we also looked at different kind of queries. We wrote queries using JPQL, and also we wrote queries using native queries. Now let's shift our attention towards relationships. What you're seeing here is a simple spreadsheet. What we have in here is the table course with the data for the course. So the course table has 2 columns, right? ID and name. I'm ignoring the update date and the created date kind of columns. So effectively, actually the course column has 2 columns, ID and name. 10,001 JPA in 50 steps. The ID is the primary key for it. So if I give 10,002, then I know it identifies only one row in this specific table. That's basically this row. So this is the course table with an ID and a name. The other tables which we want to bring in into this course are student, passport, and reviews. The high level relationship goes like this. A course can have multiple students, right? So single course JPA in 50 steps can have multiple students enrolling for it. And also, if you look at the reviews, a course can have multiple reviews as well. So one student might be giving a 5-star, other student might be giving a 4-star review, and things like that. So a course can have multiple reviews as well. The other relationship is between a student and a passport. A student can have one passport, and the passport is associated with a student. So we have different entities in here: course, student, passport, and review, and there can exist different kinds of relationships between them. Let's quickly look at the different entities. We already looked at the course entity. What we want to do is we want to create a student entity with the ID and a name. We would create a passport entity with a ID and a passport number. We'll have number as a string because the passport number sometimes can have something like E104 or E, or a letter also present in here. So we'll represent number using this string. So we'll represent the passport number using a string, and we'll have a ID and a number. And the review table will contain a ID, a rating. A rating is basically a rating of the course 1, 2, 3, 4, 5, and also a description of the rating. One of the things that you need to remember is right now we don't have any columns to represent the relationships. So who are the students for this course? 10,001? I don't really know at this point in time. We will work on this as the course goes on. For now, let's try and focus on the relationships, different relationships between these tables. So course to student. So a course can have multiple students. So this course 10,001 can have all these 3 students enrolling for it. And looking at the other way from the perspective of a student, Ranga can enroll in all these 3 courses. So the relationship between course and student is called a many-to-many relationship. A course can have many students, and a single student can enroll in multiple courses. This is called many-to-many relationship. Let's consider the relationship between student and passport. A student can have only one passport. So Ranga can have only one passport. Let's say his passport number is 12345 6. So that's the only passport he can have. Looking at the other way, a passport can only be associated with one student. So when I say E1, 2, 3, 4, 5, 6, there can only be one student which it is associated with. This kind of relationship is called one-to-one relationship. The relation between student and passport is a one-to-one relationship. I'll not go into the complexities of dual citizenship and other kind of stuff in here. Let's assume that the relationship between student and passport remains one-to-one. Let's move on to the relationship between a course and a review. A course, JPA in 50 steps, can have multiple reviews, right? So I can have a review saying 5-star. I can have another 5-star review with a different description by a different student. So a course can have multiple reviews from different students. When you look at it from a perspective of a review is always associated with a single course. So when I say review 50,001, it's always about a single course. So when I look at it from the perspective of a course can have multiple reviews, but a single review can only be associated with one course. These kind of relationships are called many-to-one relationship. You can have a course with many reviews, but the review can only be associated with one course. This is called many-to-one relationship. In this video, what we looked at are examples of the entities we would be creating later, and also we looked at the different relationship between some of the entities which are present in here. There are other relationships which exist, for example, between student and review and other stuff that you can think about. But for now, let's focus on the entities and the relationships that we talked about. In the subsequent steps, we would start defining the entities and defining the different kinds of relationships between them. Until next step, bye-bye.